Hi, this is Rich Redelfs, and I'm here with Mark Weber from the Computer History Museum, and we're interviewing Jeff Abramowitz as part of our series on the history of Wi-Fi. Jeff was the original conceiver of the Wi-Fi Alliance and has some background in Wi-Fi before that, and we'll be digging into that here today. Jeff and I work together at 3Com, so we have that in common. I'm on the board of trustees here at the museum and also a general partner with Foundation Capital. So Jeff, welcome.
Thank you very much. Happy to be here.
Great. Well, let's start off with a little bit of your background. You
Sure.
grew up in New Jersey, if I remember correctly.
I did.
And engineering degrees, and I remember Jeff and I worked with a guy at 3Com who he went to high school with, and I remember having a conversation with him about Jeff in high school. What was he like? And he said, the smartest kid in our high school. So tell me about high school and how you got into wireless.
So I guess, you know, standard New Jersey geek slash sports-loving musician would describe my background. I did play in a band in high school as well. I just went to my 35th reunion and sang at it, so that was fun. But basically, you know, high school was your standard excelling in math and science. Decided to go to University of Pennsylvania for a mechanical engineering degree because at the time I was into cars, and I thought I wanted to be an automobile designer. I actually turned down MIT to go to University of Pennsylvania because.
Tell us a little bit, though, also about where you grew up, your family, interests as a kid.
Oh, so go back a little further?
Yeah.
You want me to take it
Before
forward or
we
go
move
back?
on. Either way is comfortable. Go back, then.
Go back. All right. So, so I grew up in East Brunswick, New Jersey. It's right in the center, Turnpike, exit 9, and went primarily to public schools in New Jersey, and loved math, loved science, loved playing out in the fields. And
Was that parental influence? Was your dad an engineer or a relative? How did you lean that way?
Well, I leaned math and science because my uncle actually was a professor of electrical engineering, and he taught at Purdue, then he taught at Stanford, and then his story is he didn't like the weather, so he moved to Hawaii. And he actually worked with Norm Abramson, who I ultimately met, who of course is the father of AlohaNet. So that was pretty cool for me. So that would have been kind of the tech influence, but really it was just that I had a very analytical mind. I tended to do quite well in math. I tended to pick up concepts in science well. And so the natural progression was one towards, you know, being a geek. I had a friend, by the time I was in high school, I had a friend down the street who was putting together his own kind of homebrew computer. And I wasn't enough of a geek to really do it myself, but we would go over and when we weren't playing Risk, we would work on his computer. So, you know, nothing that would say, oh, you know, this guy is going to go do, you know, start a computer company or ultimately start a cloud managed networking company, but definitely a tech influence, and had, you know, tech-oriented friends as well.
Great. And then you went to UPenn in mechanical engineering.
So I went to Penn in mechanical engineering, and the thought there was that I like to build things. And ultimately I got very excited about robotics. My senior thesis wound up being building a mechanical hand. And that mechanical hand wound up being really the basis for what became the GRASP lab at University of Pennsylvania. So, you know, I went to.
Interesting. Is that still around today?
You know, the hand itself is not, although it was in the Penn brochures for like 10 or 15 years. And it was kind of interesting. Regina Baici was the professor who authorized it. She's now at Berkeley. She's still an icon in the industry. And there was only one hand in the industry at the time, and it was somewhere north of $100,000 to buy one. So she got me to build one for much cheaper. And so from Penn and robotics at Penn, I actually went to MIT for grad school, and I got a degree in electrical engineering. And I had done a fair amount of electrical engineering undergrad as well to set myself up for the robotics department at MIT. What happens is, at Penn, robotics was mechanical engineering. At MIT, robotics was electrical engineering. I went to work for the guy that built the Stanford JPL hand, again, thinking that robotics was where my career was going to wind up. And I took robotics and control theory courses. But alas, that's not where I wound up.
So when did you graduate, and where did you go initially out of MIT?
I graduated in '85, and I wound up going to a startup in San Diego that did essentially radio products for, it was a subcontractor to the military.
Now that had to be a tough decision after doing all this robotics.
Right, and I missed a piece there. So what happened, the most influential course I took at MIT turned out to be a course in entrepreneurship. I was on track. I was accepted to the PhD program at MIT in mechanical engineering. I took this entrepreneurship course, and I said, that's what I want to do. And so I got bit by the bug. I wrote a business plan for a floor cleaning robot at MIT.
You could have been Roomba.
I could, except that the economics were completely upside down, right? And there was no way I couldn't see a way to make it successful. And then when I was looking for jobs, what I realized is that there really were no jobs in robotics per se. So the attraction to this startup in San Diego was I was going to learn to design radio products, and then I was going to automate the production of those radio products. Only there was no automation to be done. It took me about 3 or 4 days of being at the company to realize I'd kind of been hoodwinked in some sense, and I became a radio designer. Then I became a manager of the team that was designing these radio products.
When you say radio designer, what did that mean?
Oh, microwave components.
Okay, so you're actually a chip designer.
Not really chip. It was actually filters and switch filters, etc., that go into military subsystems.
Okay.
I skipped the part where I worked for Hughes Aircraft during the summer, and so I worked at Hughes Radar Systems, and I'd done some target altitude error equations. One summer, I did some other things in and around radar. So I had some familiarity with wireless systems,
so
but now
like
I was
designing SAW filters or something.
Basically, and other types of your standard component RF filters. Yeah, they had the advance that had been made was really taking personal computers and using them to be able to design custom components for the military. And it was, when I joined, the fastest growing military subcontractor in the history of the United States. That was the lure. So, so I went there and did what I didn't think I was going to be doing, and I stayed there. First I was just managing the team. Then I wound up actually managing the product line, which was great experience, and helped get me into business school, which was where I went next.
Great, and that was Stanford? So
I went to Stanford, and I got an MBA, and again,
finished what year?
1990.
Okay.
And what's interesting there is I graduated with my class, but I actually stayed a little bit longer. I did a semester in Japan, and then I worked in Japan. And again, still interested in automation and robotics. Still thinking I was going back to automation and robotics. I worked on a factory floor in Japan, and I designed a production process for a smart gas chromatograph. That's what I remember.
Because in that era, Japan was really leading the world in robotics.
That's exactly right.
I was an industrial engineer, and I had the same desires, but it was hard in the U.S. to get a job in robotics.
Yeah, yeah. So I went, so that's what I did, and I came back and I graduated.
Was that automotive related, tying back to your interest in auto?
The automotive went out, the U.S. auto industry was...
But Japan, that's where a lot of their robots were developed around, right?
That's actually true. I had gotten a job through Honeywell, so it was control systems, home automation, which actually ties looking forward, but not auto yet. We'll see if we can do that sometime in the future, I guess, is the thought there.
Yeah. Okay, so you were in Japan, and then?
So I came back, looked for a job, and I wound up at a startup, only just incredibly funded startup, $183 million, mostly from Kleiner Perkins. Domestic automation was distribution automation, demand side management to essentially automate the communication systems for utilities. So everything from a smart meter to a pole-top radio to a cellular base station. So that's where I really got into radio systems.
So this was Cellnet.
This is right. So domestic automation changed its name to Cellnet, and I took a side course on networking to kind of understand how all of these pieces and all the data would flow, and that was a great experience. Except that I learned that the utilities are not the right end customer for innovative technology. So you can build the best mousetrap and you can potentially get a pilot, but after they've got the pilot going, you might have to wait 5, 10, 15, 20 years until things actually get deployed.
So you were a Stanford MBA with a MIT and a Penn engineering degree. You probably had your pick of jobs. Why did you pick that one out of business school?
Well, I definitely wanted to be in Silicon Valley technology, and I was excited about radios and wireless connectivity, and the VC. I remember sitting down. And I've forgotten the gentleman's name, but sitting down with the VC and him giving me the big vision. I was sold. So Paul Cook was the CEO, and he was an industry icon. Doug Spring was the president of Cellnet Data Systems at the time, and he was very convincing. And so I had I had an offer to do to have a much better title at Honeywell, for example. But I thought that this would offer me the best growth opportunity.
And it tied in with your entrepreneurship interests as well, it sounds like.
Yeah, that's exactly right.
Great.
Yeah.
So you were there how long? And it sounds like you figured out pretty quickly that was a tough place.
No. I was there actually
for
I was there for about 3.5 years. And what happened was things were going gangbusters. Then Schlumberger had a competitive product on the meter side. The company went from 180-something employees down to 43. So
it was going gangbusters in revenue, and yet
no, it was,
you lost market share?
Yeah, it was going gangbusters when they hired me, and then Schlumberger introduced a competing product. Prices got cut in half, and the company started bleeding cash like crazy. So we had a RIF of the month for the next 12 months. It was incredibly painful, but we still needed to get the product out. So we just cut down to a core team. So
the product, when you say it was going gangbusters, was that in revenue or just in terms of?
No. So what was when I joined,
right.
For example, the smart meters were seemingly going gangbusters, but then when Schlumberger announced the competitive product, it cut sales, cut revenue.
Got it. Because you said you had to get a product out, and I wasn't sure if that was a second-gen product or a standard product.
Yeah, I'm sorry. A little bit more complicated than that. So Cellnet had a electric meter business, which was their core business, and then they had this whole, call it the Cellnet radio system, which was going to be the meter, the pole top, and the cell tower. And so the goal at the time was that this meter business was going to help fund the investment in this whole communication system. And so what happened was
So you went from a dumb meter to a smart connected meter.
Exactly. And what happened was when Schlumberger basically entered this market or cut prices in this market, I don't remember which, they basically killed what had been thought to be the cash cow, right? And now all of a sudden everything that was being built over here had to be scaled down, but we still needed to deliver this complete communication system.
Got it.
So we went from, and it was when I joined, it was kind of a plush company, and I would say a year and a half later, we were pretty tight. And in fact, so I'll tell a little prank that I pulled. The company was DAC, and we had a very nice building. We had all these, huge space because we were going to expand. And then when we cut down, we had all the office equipment that we had, I guess, leased. And so we wound up putting all of it in one half of the building to give back to whoever we were leasing it from. So I put a sign on the front of the building. One night, let's stay working late, I put a sign and it said, instead of, I'm going to get in real trouble for this, instead of domestic automation, I changed it to say dividers and chairs. And put pictures of all the dividers and chairs.
You have people knocking on the door the next day to buy your chairs.
All right, that was my prank story. So,
by the way, did the management figure out it was you who did this, or this was a big secret?
it was a secret for a while, but I had also changed all of the conference room names at some point. So I think I was known.
You were a troublemaker.
I was a prankster. I was not a troublemaker.
That's good. Every company needs a little sense of humor, particularly when you're going through tough times.
Yeah, yeah. I actually just remember we did when we changed the conference room names. I put a poem on each conference room explaining the new name. Unfortunately, yeah, the names didn't stick.
Yeah, more creative names than, like, for instance.
We would not have used Princeton. That would have been bad. And I.
No, for instance. Yeah.
Oh yeah, yeah. But I don't remember.
You don't remember any conference
No,
names?
I don't. They were numbers, right? And I gave them personality.
Sure. That's become a Silicon Valley trend.
Yeah, actually,
now.
I'm sure I didn't start it, right? I'd heard that other folks did that, and I said, yeah, that sounds like fun, and we could use some fun. So
that's great. So then layoffs at Cellnet.
Yeah, but actually things started to
TAC.
grow. So actually, here's what happened. Things started to grow, and I was put in charge of the engineering team.
Wow, so you went from product management to engineering.
Well, I was really, right, I was an engineering group manager. And I'm thinking to myself, wait a second, that's what I was before business school. So I don't know that I was actively looking, but what happened was somebody at 3Com found me. It turns out that Doug Spreng was the EVP in charge of the adapter division. 3Com was gangbusters at the time. That was truly gangbusters.
Right.
Cellnet was kind of mouse nuts compared to what was going on at 3Com. It was 93, 94. You were there, right?
Right.
You were probably already hanging on by
build
your
them fast
fingertips.
enough, yeah.
Yeah. So Powerhouse in Ethernet was already investing in Token Ring and other technologies. In late '93, I learned they had bought technology from a company called Pacific Monolithics. And so the vision that was told to me was, we want to be the dominant player in wireless networking. And they had, I don't remember whether it was already, thought to be enterprise, then small business, then home. But it pretty quickly became that, with this understanding that 3Com really was going to take this technology to the next level.
Yeah, if I remember, the belief at the time was 3Com really dominated the Ethernet NIC business, over 50% market share, and wireless was
just the next step
generation, and yes. it was ours to lose.
Yeah, it was truly remarkable too, because it was a great standards-based story. It was founded on Ethernet, and then 3Com had parallel tasking, right, which was really just a slight proprietary enhancement that got marketed well, and it enabled 3Com to grow the business, which enabled them to drive down costs and get a lot of profit in a business that was seen as a commodity.
Mm-hmm. And huge gross margins that Wall Street didn't even
understand. That's exactly right. And then what that also enabled was just a nice channel build out. So the 3Com channel really was the envy of everybody in the space, which became important, as we move forward talking about Wi-Fi, from the perch at 3Com, people wanted to do business with 3Com. My entire career at 3Com, people would come in the wireless space, would come to 3Com and say, if you would just take our technology, this would be ginormous.
Right, right. So you came over basically to lead marketing of the whole wireless initiative.
Exactly.
And you came after the Pacific Monolithics?
I came 6 months after. The project had already started.
Right.
And my first meeting there was actually a review of the program. I think it was supposed to get delivered in late '94. When they bought the technology in late '93, it was supposed to get delivered in late '94. And my first meeting was the first real audit of the project. And it really was masterfully laid out, but that was also the first time that the project got postponed.
Right.
Which, as you know, happened time and
yes,
time.
Yes, this is the project that was a year away for 3 years, right?
Unfortunately true. Now, potentially fortunately for the industry, but unfortunately for 3Com.
Right. And talk a little bit about what that technology was and why did it attract you? Because this was before, well, way before Wi-Fi, but even before IEEE 802.11 had any momentum, right? The original spec was...
The original spec, so people were working on the spec,
right.
And it was a time for wireless data hype. Right, people had started to envision this notion of wireless connectivity. You had POM, but you didn't have a connected POM. You had computers, but they weren't. Laptops, and laptops were growing, right? Because 3Com was making money shifting from desktop NICs to PCMCI NICs, which you ultimately led the division for. So that's where the industry was, and so it became clear that, not clear, but it seemed for folks in the space that the wireless was the next great thing. And there were conferences going on, you know, espousing the different technologies. Actually, step back, I went to a conference right when I started at 3Com, maybe even actually just before. For me, it was helpful for me to try and make my decision. Craig Mathias was one of the speakers who has been an analyst icon now for years, but this is in the early days. And I signed up for 15 minutes with Craig. You could sign up for 15 minutes with an expert as part of this conference. So I signed up for 15 minutes with Craig Mathias. And in the conference, you had Proxim talking about their technology, Symbol talking about their technology, Intermec talking about everybody was talking about their proprietary technologies. And I sat down with Craig Mathias and I told him, you know, I'd gotten permission to have this conversation, you know, here's what 3Com's planning. He was like, wow, right? He was standards oriented, but he said, you know, 3Com could really help propel the industry.
And what did you think made 3Com so compelling versus all these other proprietary standards? Because 3Com's, what they were working with was proprietary as well at the time.
Correct, but none of those companies had any type of marketing. In fact, if you went back and looked at what was being promoted at the time, you know, Symbol's marketing collateral would say, our technology is better than Proxim's technology. And Proxim would say, our technology, right? And if you're an end customer, it's like, okay, what am I using the technology for? There was no, there was kind of this missing overlay of, well, what are the benefits and uses of the technology?
Right. But wasn't a lot of it very vertically oriented?
It was vertically oriented.
It was factory automation and it was retail POS systems. But it wasn't office automation. It wasn't connecting PCs.
You are exactly correct. But even for somebody that was, I mean, healthcare was thought to be a target application. And they didn't say, here's what you can do with your wireless as part of healthcare. It just said, our technology is better. Right? Assuming you want to do wireless, we've got it better than they did. So the thought was, okay, 3Com's a great place to go help move the industry forward. One of the interesting things is that 3Com's perception of where the industry was when they made the purchase was not actually accurate. So
tell me more about that.
Yeah.
Where was the perception and where was the reality?
So one of the first things I did when I joined 3Com, the best first thing I did was go out and talk to end customers, and we wound up running market studies. I'll come back to that. The other thing I did was I looked at the market research to try and understand how to steer the product that we were building. And what I discovered was that market research in the wireless networking space was horrible. Horribly optimistic, but horrible. And the one stat that I remember was that Proxim had gone public in December of '93, just about the same time that 3Com bought the technology. And their sales were something like $8 million revenue for the whole company. And I had a market research report that showed that they were selling $40 million worth of wireless networking equipment.
And as a publicly traded company, you could see that.
So I called the analyst. Of course, the 3Com, I have access to the analyst. I said, well, how could they be selling $40 million worth of equipment if their total revenue is only $8 million? And they're like, well, how do you know that? It's like, because they're a public company.
Yeah.
So 3Com had the market research. It said that there were going to be 1 million nodes of wireless networking equipment sold in 1995. And I looked at, and that was, building off of the current base. And I remember going in one weekend and having 7 market research reports and trying to cross-check them. And basically, I came up with the fact that the industry was going to be about 100,000 nodes in 1994. And maybe it was going to see 20, 30, maybe 50% growth in 1995. But it was 1/10 the size of the market that 3Com thought when they bought the technology. Mm-hmm. So what then became a priority was, well, if we're going to introduce a product into the space, it needs to be a meaningful space. So you don't have a product to promote yet. Product actually just got delayed. Go promote the industry. Mm-hmm. And so,
but you also did a lot of market research on. I mean, I remember you're initiating a lot of market research on what was the market really looking for.
Yes, thank you for...
Because one of the things, most of the stuff shipping was 1 megabit.
No, you're exactly
and
right.
wired Ethernet was 10 megabits. And I remember the Pacific Monolithic technology
was 10 megabits.
And all the IT guys said, we want it to behave like wired,
that's right? That's exactly right. So we went out and we did a market research with folks that had... We did both. We did...
And that was you hired Carl Temme.
That's exactly right. That's actually, so that was one research project. We had, I mean, we actually did multiple research projects. 3Com was really keen on getting this right. So the idea was to go and talk to actual end customers and get that feedback, which we did. Then we audited folks that had wireless networking and got feedback there, and then we audited, we surveyed folks that didn't have wireless networking to find out, well, what would they want? So what we discovered was folks who had wireless networking, regardless of whose wireless networking they had, and you're right, it's all 1 and 2 megabit, loved it. 95% of the people we surveyed, and it was probably, I don't know if it was north of 100 people at 100 companies, 95% said they wanted to buy more. And this is at 1 or 2 megabits. Their primary knocks on what they had was they wanted it faster, they wanted Ethernet speed, and they wanted it cheaper, because access points were, I think, $2,000 and adapters were $500 or $600 a pop. So, there's one thing about technology is it's going to get faster and it's going to get cheaper.
So what was a wired NIC? So these were $500 for 1 megabit wireless. What was
you had to buy
10 megabit wired at the time?
I don't remember what it was at the time, but I remember that the threshold, 3Com said that the threshold for adoption was $300. If you could get a NIC under $300, it would be a mainstream product. And so the 3Com project really was targeted at that $300 price point for the NIC. And we actually were certain we could get under $1,000 for the access point, which would be, a significant drop. We didn't know that we needed to, because it's an infrastructure product, and so it wasn't clear what the pricing needed to be. So, I saw the market research, and I was totally hooked, and it became wireless networking evangelist. Like 95% of people want to buy more. That's pretty good. That's a pretty good repeat rate. And of course, the people who didn't have wireless, the key reason they said they didn't have wireless because it wasn't fast enough. Mm-hmm. So there's all this excitement of 3Com. Got to get the product out. And there's other stuff happening in the industry, but it's all with.
Right.
Seemingly moving
forward.
Where
did the original 802.11 come out? Somewhere in this time frame, wasn't it? And that was
not quite yet. So it was.
That was later. Okay.
It was hatching. It was hatching very slowly.
It took like 6 or 7 years to get through the standards, And then it was 3 different PHYs, non-interoperable.
That's exactly
and
right.
1 megabit.
1 and 2 megabit.
And 2 megabit, right.
So yeah, the notion that 802.11 was going to be...
This is IEEE 802.11.
IEEE 802.11.
Right.
The notion that it was, in 1994, 1995, the notion that it was going to be truly be competitive was kind of, well, it's taking forever. But there was still promise there.
Right. And Proxim got some momentum behind Home RF, right, which was
that came. They actually
was
had
that later too?
That was a little bit later. They had Open Air, which also came a little bit later. Okay. So what I remember is in 1995, and I think by this time you were now in the wireless group, ran the wireless group. I worked for you, and I went to the IEEE meeting. I got to go to Hawaii. That was good. I actually was a voting member of the IEEE. I signed the original standard, and I believe I may have signed the high-speed standard as well. Winds up being important for a later story because you have to go to a certain number of meetings and participate and also provide feedback on the sponsor ballots in order to have your voting rights. So I had voting rights. I went to the meetings to understand what was happening with the standard. So I went to the Hawaii meeting in '95, and I pitched this concept of an industry organization, the Got Milk organization, to promote the benefits and uses of wireless networking. And I got people to agree. And I got frequency hopping folks and direct sequence folks. I don't know if I got the IR folks, I don't remember.
So explain direct sequence, frequency hopping, and IR, and what that had to do with this.
Right, so as you mentioned before, the 802.11, IEEE 802.11 standard actually had a common MAC, medium access controller, and 3 different PHY layers that you could use to be standards compliant, which creates kind of the interesting predicament that says you can be 802.11 compliant and be completely non-interoperable with another standard product. So Symbol, for example, and Proxim were big on frequency hopping, and Lucent, who probably had the most market share, was big on direct sequence. And it wasn't clear at the time whether frequency hopping was going to win or direct sequence was going to win. They were both 1 and 2 megabits, and so in order to, and this...
And by the way, Lucent was Vic Hayes and Case Links, who also have done interviews for this series. And,
that's correct.
And Lucent became...
Well, it started as NCR, then they became Lucent, then they became a Gear.
Right. And many different companies with the same team.
Right.
Right.
They did yeoman's work for the standard, right? And IEEE 802.11 wouldn't exist without Vic's stellar leadership as part of the IEEE committee and the support of Case and other folks behind them in the Netherlands. Now, they were making money, or seemingly making money, or had a prospect of making money, but not only did they continue to support it, but Vic, as a chair of 802.11, was squeaky clean. He did a really nice job running the meetings. He was squeaky clean. That actually will come up again in a story I'm about to tell, because you knew that Vic was always going to do the right thing. And I think in terms of the overall industry coming to fruition, one of the everybody knew you could depend on Vic as the leader of the...
But there were a lot of politics underneath Vic's leadership, right?
Huge politics.
There's all these different PHYs and different proponents for...
That's exactly right. And in the early days, so the thing about IEEE is you're an IEEE member as an engineer, presumably. I was kind of a pseudo-engineer. Technical enough to make some contributions, but not really down in the nuts and bolts. But the notion was you were there representing yourself and your own ideas, not necessarily your company, right? And in the early days, it was pretty easy to be altruistic because there was no money to be made. There wasn't much of an industry, right? So people actually proposed, right, the best technology, and there was this real, and there were people who were consultants who would then get jobs at other companies. One of the guys I remember was Greg Ennis, was a consultant to Symbol, right? And he was just a voice of wisdom in the IEEE committee. We later hired him to at 3Com as a consultant, and then obviously he wound up being the technical chair for the Wi-Fi Alliance, and there's a pattern there. But people would go to these meetings and try and move the standard forward, but then you had the politics of companies trying to either position their company to be able to take advantage of the technology or block somebody else's technology. And so it really was this slow-moving beast that was happening in the background. So I would say late '95, I went to the, it was, I guess, maybe July of '95, IEEE meeting, formed this organization that's really just going to be, why can't we all just get along? And we're going to go promote the benefits and uses. And people said, oh, if 3Com's going to use their marketing muscle to move the industry forward, it sounds like a good thing. And so we signed on. I got 7, then 11, then some number of companies to all say we were part of this organization. And we helped straighten out the market research companies because they didn't really understand what was going on in the industry. And we were attempting to just get the press and the technical community to understand that there was this big opportunity coming. And people would say, well, what's happening with the standard? And the standard was coming. It was coming. By middle of 1996, it actually looked like the standard was final, or going to be final. It didn't get formally approved till September of '97, but it was pretty well baked. It's just there's a bureaucratic process that takes almost a year before things get officially approved. So by the middle of '96, it looked like there was going to be a standard. It still wasn't clear whether direct sequence or frequency hopping was going to win. But there was a migration towards using the 802.11 MAC. 3Com, we looked at, well, can we make ourselves standards compliant in some way, shape, or form? The 3Com project actually pushed out again. So now it looked like it was going to come in 1997, right? And the Standards Committee was already talking about higher speed extensions. I had given a talk, I used the 3Com market research, and I gave a talk at the IEEE meeting and said, okay, we need to get 1 and 2 done so that we can get to higher speeds. And so that got put on the docket. A got put on the docket as, so this, why did B come out before A?
This is IEEE 802.11 B and A, which
and
followed the original one.
That's right, okay. Yes, thanks for clarifying. And the answer, as I recall it, is that 802.11a was at 5 gigahertz, and the standard didn't say anything about 5 gigahertz, so you could propose a high speed at 5 gigahertz. You couldn't actually propose a standard at 2.4 gigahertz, a high-speed standard at 2.4, until the original standard was completed. So A was made as a proposal, or was offered to Execom first, and then B came second, even though obviously in the market B came first and A came second. So, so what's happening with all this? Well, Glenn is starting to promote benefits and uses. People are moving towards the standard. 3Com, we wound up canceling our internal development effort because we had done, we'd had conversations with folks and said, the high-speed standard is going to be comparable to what we were planning on doing internally. It's going to be a standard. We still have the market power. We think that we can do better with less investment by leveraging a high-speed standard. And I wound up going on a tour. We hired Greg Ennis as a technical expert to accompany me and the guy who had run our engineering project, David Fisher. And we went to Palm Bay, Florida to talk to Harris, which became Intersil. We went to the Netherlands and talked to Lucent. We went to Israel, talked to a small company called RDC, and we talked to Breezecom. And then we went to Ohio and talked to Aranet. So we basically did an audit to find out whose high-speed technology we thought was going to win. The IEEE, because the thought here is potentially jump the technology, partner with the folks who are going to win, bring that technology to market, and grow it. So, so that was all happening in the 96, 97 timeframe. And it was exciting times, but was kind of waiting for Godot because the standard wasn't quite there yet.
So this was, when you say the standard wasn't quite there yet, you're talking about the B standard?
No, actually,
the original one was...
So the original was 97, right? So
ratified
as soon as 97. As soon as that got ratified, then all this effort went into 802.11b.
Right.
And once people realized that there was going to be a greater than 10 megabit per second standard, there were rumblings of Apple getting involved. Microsoft put out an RFP. Ultimately, Cisco wound up buying Aeronet in 1999. You had...
Right, and if I remember, Cisco bought Aeronet to get the Microsoft campus business.
So that's the rumor, and it makes perfect sense. And to grow the wireless business as a whole, right? Because once Microsoft became a bona fide deployment, that obviously is mainstream, right? That's a marquee customer that somebody could use and say, Microsoft's got wireless networking, you should too. So,
yeah,
by the way,
they did a huge campus network.
They did, and they did. You know, 3Com was obviously part of that audit by that time. So let me just back up a second.
Yeah.
So now 3Com has decided that that we're not going to do our internal development. We're going to partner. We originally, this is interesting history. The results of our audit in early '98 were we liked the Lucent technology best. I went to the Netherlands, met with Case, further conversations with Angela Champness in San Diego. I mean, it was kind of one of this, we're going to go figure out. And
Case was the VPGM of the unit,
Case,
and Angela was head
the
of marketing.
head of marketing
right.
for, yeah, thank you, for I don't remember whether it was Lucent at the time or whether they changed their name, but it was the Waveland technology. And the challenge was that they wanted to be a systems vendor. They didn't want to become an IP supplier or a semiconductor vendor.
But just to be clear, this was their 802.11b that was in development.
That's exactly right. It was not quite B yet, right? This was the technology that was vying to be 802.11b.
The B to B.
The B. That's going to be tough for folks to follow, but yes. Yeah, so we looked at, what we actually looked at was the Lucent proposal for B, the Intersil proposal for, everybody's proposal for B. And we decided on Lucent, and then we couldn't come to deal terms because they were not willing to license the technology or sell semiconductors to 3Com. And we wound up putting together an alternate path to market, which was to leverage the Harris technology, and Symbol, who heretofore had been frequency hopping, realized that frequency hopping technology was not going to be able to go faster than 2 or potentially 4. They had a way to get it to 4 megabits per second. So they were going to make the switch from frequency hopping to direct sequence. And they were going to partner, it was going to be this triad, Harris, Symbol, 3Com. And there was a little uneasiness with all members of the
yeah, and just to be clear, Harris became Intersil, and they were the chip company.
They were a semiconductor company.
Right.
They were going to provide the semiconductors to Symbol. Symbol was going to build modules, both a PCMCA card and then also an access point that 3Com would then brand and sell as 3Com's wireless infrastructure.
Right, with the idea of Symbol being more vertically oriented toward retail and industrial systems, and 3Com would take it
into the mainstream.
Into the mainstream office automation space.
That's correct. Yeah, and that worked well from divvying up the market standpoint, right? Great, they've already got, retail was really their strength. So we would take that technology, take it to mainstream. We had a network management software effort that we were going to overlay on top of it to help differentiate the solution for the enterprise. We had some other things going to try and figure out, well, how are we going to get this technology into small business in the home? Because we knew we couldn't OEM from Symbol and get the low cost, but we thought we would get the quality from Symbol. But we were a little concerned about how committed Symbol was to direct sequence. So what I wound up doing is signing a letter, and I remember this pretty distinctly. Ron Vandell ran the wireless business for Harris.
Right.
And Rich Braverman ran the... Brovman, thank you.
Yeah.
Ran the business for Symbol. And we wrote letters of agreement that we would form an interoperability organization based on the 2B high rate standard. And that really was the basis for the Wi-Fi, what became WECA and then the Wi-Fi Alliance. So those two vendors were already part of WLANA, right? So we were having these quarterly Wireless LAN Association meetings. People were asking, well, why isn't
WLANA, we haven't talked about that.
Okay. So WLANA was that organization, so I started on it and then I distracted myself. So when I went to the IEEE meeting and I started this Got Milk organization, it was called WLANA. Originally it was called the Wireless LAN Alliance. We actually changed the name to Wireless LAN Association. And the reason we changed the name to Wireless LAN Association was we knew we wanted to form an alliance that was actually going to have interoperability testing. There was no real alliance in WLANA. It was just a bunch of companies that came together for marketing purposes.
It was just marketing wireless as a whole without any sort of value add.
Right. And then people said, well, why can't WLANA do interoperability testing, right? There was an increase in, there was this, say, okay, now you have an 802.11 spec. The 802.11, the IEEE doesn't say anything about interoperability. And you can have 802.11 products from one company and 802.11 products from another company, and they could not work together. So there was a clear issue that needed to be addressed. There was an industry association that needed to be formed. It had happened with the Ethernet Alliance. It happened with Fast Ethernet Alliance. By the way, it happened with the Token Ring Alliance. And in all three of those cases, by the way, 3Com was the company that formed the alliance. And I used the charter for Token Ring Alliance. Wendy Wally had been the chair of the Token Ring Alliance, and she gave me her charter. And I used that for cost-saving purposes to start WLANA, and we stripped out the interoperability testing because we didn't need to do any. But then WLANA had no provision for interoperability testing, and we had folks who didn't necessarily want to do interoperability testing. We still had folks like Proxim who were developing their own proprietary technology. So we realized you have this WLANA organization, which is just marketing, that we needed an interoperability organization. We signed with Intersil, what became Intersil, and Symbol to do an interoperability organization. They said, well, who else do we need? And we wound up, of course, contacting the folks at Lucent and at Aeronet. Those were the two market powers. They were both in WLANA, and said, you know, we want to do this interoperability organization. Are you guys in? So one other key piece of information here is that at 3Com, with this notion of doing Wi-Fi for the enterprise, Wi-Fi for small business for the home, sometime in late 98, late 97, early 90, no, sorry, late 98, early 99, I hired David Cohn to be our small business consumer Wi-Fi guy, but then also presumably to help with this new organization, because I didn't think I was going to wind up doing both organizations. I didn't know that I really wanted to do any organizations. But
so you were still doing WLANA at the time?
I was still doing WLANA. It wasn't really a big effort, but the WECA, getting something off the ground is a lot more. When I got WLANA off the ground, there wasn't a lot of product stuff to do. But I saw that WECA was going to be a fairly significant effort.
Assuring interoperability is a lot of work.
It is a lot. That's exactly right.
It takes resources and as opposed to just general marketing.
That's exactly right. So I sat down and talked to David, and he was excited about it. So he actually made the call. David Cohn.
Oh, got it.
So sometime in '99, told him about the letters, told him about the plan for WECA, and then I don't remember whether it was July or August. We had our WLANA meeting, and
you mentioned WECA. I just want to clear what is the name WECA.
So the WECA stood for Wireless Ethernet Compatibility Alliance. And again, I don't remember if we called it that, whether we referred to it as that before it was formed, but that was the initial name for what is now the Wi-Fi Alliance. So you had WLANA, you had this concept of Wireless Ethernet Compatibility Alliance, we had a meeting at 3Com with the Wilana folks, and we had a pretty good team. We held that meeting, decided whatever we were going to decide. We marched downstairs to the 3Com front entrance. We said, goodbye to Proxim. We said goodbye to the Wilana director, and then a bunch of folks marched back upstairs, and we had the first WECA meeting, and came up with, okay, here's what WECA is going to be. And of course, it was centered around the interoperability of the high rate product. By that time, I've jumped ahead. By that time, the standard had already been pretty much, no, actually by that time the standard had been nailed down. The standard was if not fully ratified, essentially ratified. So there was no question what products, what the technology was that needed to be tested. Nobody had product yet. Some folks had done some interoperability testing amongst themselves, but there needed to be a formal process. Greg Ennis was hired to be the technical director and help figure out how the interoperability testing was going to work. He was known to us, he was known to Symbol, he was trusted elsewhere. And Phil Bellinger from Aranet became the first president, and David was the vice president. So it wasn't a pure, 3Com organization. And the structure was such that only the founding members had votes, which wound up being important going forward for the Wireless LAN Alliance. Having a seat at the table for the Wi-Fi Alliance wound up being pretty key. But the first order of business was to figure out the name, and the organization called itself the Wireless Ethernet Compatibility Alliance. But at 3Com, we were very convinced that the name for this technology needed to be something which was consumer friendly.
You mean IEEE 802.11b doesn't just roll off your tongue as a good marketing name, Jeff?
Nor does wireless Ethernet, right? Because people didn't necessarily, well, Ethernet's successful, but was the argument, yeah, but the reality is 3Com truly had bold plans. We had bought U.S. Robotics at that point. We'd already named 3Com, Candlestick Park was already 3Com Park. And so the idea here was, and we had hired Interbrand to do some corporate branding.
And Home RF had a bit of momentum in the residential.
You're right. Home RF
Motorola and Intel were promoting that,
it.
Right?
Right. They were just, I think that conceptually was starting. And so, yeah, the thought was, okay, this needed to be a consumer-friendly name. And fortunately, the WECA started with enough, there was, in order to make sure folks were committed, and I don't remember the exact dollar amount that folks had to contribute. WECA had some money. They didn't have it, but they had it, committed. So, and you may not remember this, I remember specifically, it was your budget, which was my budget, approving a 3Com to front the money.
Right.
To Interbrand.
I do remember that, believe me.
So it was, and we got them for cheap. It was only $30K, but we fronted the money to come up with the name. And I remember talking to David Cohen because he was, very concerned that we were going to come up with this name. People weren't going to like it. The question is, what's going to happen next? Fortunately, the battle over whether we should have a name was far, far greater than what happened when we came back with the name. Because Interbrand came back with a bunch of different names. One of them was Wi-Fi, and everybody loved Wi-Fi.
There was some controversy about Wi-Fi, I remember, though. That it had an old school, kind of like a retro feel, because hi-fi was sort of out of vogue. We now had digital CDs, and there was a bit of concern about that.
Well, what happened was people would say, so the way that Interbrand got to Wi-Fi was, they would say it was informed by the term wireless fidelity, right? It's not hi-fi, so like hi-fi was, right, this would be Wi-Fi. And they were saying, don't use wireless fidelity, just use Wi-Fi, make it an empty vessel name, but you know, there's some potential positive connotations, and some people thought there were some negative connotations. And so there was this, you know, debate. Did it mean Wi-Fi? Did it mean wireless fidelity? Did it not mean wireless fidelity? The Alliance first said, you know, oh, we're not going to say Wi-Fi, and then they said, oh, we are. You know, we put the logo that said Wi-Fi, the standard for wireless fidelity. So I think the Wi-Fi Alliance had its own mishigas in and around, you know, should we use it, should we not use it? Fortunately, right, the term Wi-Fi became as well adopted, more adopted than anybody could possibly have hoped for. And so it wound up being just a resounding success.
And what was the problem with wireless Ethernet?
Oh, the key challenge is that, first of all, it's not trademarkable, right? So the thought was if you're going to create an interoperable brand, you want to be able to put a seal on every box that is trademarkable. So anybody could claim they had wireless Ethernet, whereas only folks who'd gotten approval could claim Wi-Fi. So that was one, and then the thought was just that when people use this in their homes, they would refer to it as something fun, as opposed to wireless Ethernet. The other competing technology, actually I just remembered, was Bluetooth, which was kind of a weird name, but you know they had come up with their own empty vessel name.
That was named for a Danish king or something,
right?
right?
That's right. They went through this. Intel went through this whole thing about how what a wonderful name. It was like, okay, it's kind of weird, but we liked Wi-Fi a lot better.
Right. So we will come back to some of the futures of Wi-Fi, but I also want to step back to before 802.11b. There was a big battle in the standard.
That's correct.
To which proposal? There was a Lucent and a Harris.
Oh,
I think they were Intersil at this time.
By that time, let's see. They were still Harris.
They were still Harris, and this was at the point where 3Com had decided not to partner with Lucent and had decided to partner with Harris.
Right, although it's not clear, I don't remember whether Lucent actually knew that. I think they probably did know that at the time. Right, so what's happening, so thanks, yeah, this is the down, so now 3Com had done our audit, we decided on Harris, but the IEEE has this process of honing the spec, and they had to hone the MAC layer to make sure that it could meet the needs of the high-speed PHY, and then you have to choose the high-speed PHY. And with 802.11a, the choice came down to an OFDM proposal by Lucent that was also adopted by Hyperland in Europe, and an alternate, which I don't remember the name of, by Broadcom. And it was kind of a landslide victory for Lucent in 5 gigahertz. So 802.11a kind of sailed through the adoption process.
But I think that the mindset at the time was also like, that's expensive future technology.
That's
5
right.
gigahertz.
That's exactly right.
So people weren't really focused on it, and were using it as a trading chip.
Yes,
right?
that's a good point. And the notion was 5 gigahertz is off in the future, right? What's really important now is a high-speed version at 2.4 where everybody knows how to build it. So
and just to be clear, the 11A was 54 megabits of throughput. The 11B was 11, and then the original was 1 and 2. So these were big jumps up in performance.
Yes. So, correct. So the OFDM modulation for, and which we were allowed to do it at 5 gigahertz, gave you the 54 megabits per second. And so the battle for 802.11b was who was going to define that PHY. And if somebody was already pretty far along in defining that PHY, that would give them a market edge. So you had the battle.
Time to market edge.
To the time to market edge. You had this battle. And the odds-on candidates were Lucent, who had probably the dominant share of wireless networking in the market by that time, and Intersil, who was really lining up to be the only pure silicon provider in the market at the time. And then there were some smaller companies. TI actually had it was a startup that TI bought called Elantro that had a proposal, and a small company called Microlore out of Boston had a proposal. The Microlore proposal was technically very appealing, but it didn't actually have backwards compatibility to the core standard, which violated the execcom overarching goals. Nonetheless, it was part of the consideration set. The IEEE process kind of came down to this big meeting in the Netherlands, probably somehow timed, due to politics. Again, because you want to have as many voting members at a meeting as possible. It takes time to get your voting members, and then voting members have to be present. So the presumed decision meeting is May of 1998. And it looked like Intersil had enough folks behind it. There's all the back scenes trying to get folks to support it. But Lucent might actually have gotten a shot, depending on what happens with the other folks who are not as well supported. So you have, I think, 6 proposals that get voted on, and the one that has the least number of votes goes away. Then you have 5 proposals, and then you have 4. So you get down to 3. And the assumption was it was going to be Intersil versus Lucent when it gets down to 1 and 2. But some weird dynamics occurred, and in the penultimate vote, you wound up, instead of Microlore getting dropped, Lucent got dropped. And so now the committee is voting between Harris and Microlore, who a lot of people weren't quite familiar with. And then in that vote, Microlore actually won. And
they won because it was a better solution, or because the Lucent guys were sort of anti-Intersil?
So they won because they got the most votes.
Right.
And you're not allowed to ask them why they voted. Right. But
because they're supposed to vote for as independent engineers, not for the company they work for.
They're supposed to vote for exactly right. So there's one guy in the room who maybe has a vested interest over here in the Intersil or Harris technology, and the whole IEEE process, I think I mentioned before, has these Roberts Rules of Order associated with it. There's a lot of bureaucracy that comes with each of these votes, et cetera, et cetera. So I pulled a...
So Jeff, you're famous for this now, right? So you have to tell the story in all modesty.
I said, I posited that there was block voting on that last vote, based on
and define block voting. You have to get into the details of Robert's Rules, because you're the only guy in this group of engineers who actually knew what paragraph 47, subparagraph 18A meant in Robert's Rules of Order.
So what it meant for the IEEE was that the engineers were not actually voting as individuals, but they were voting with their company. And I didn't have hard evidence, but on the surface, it would seem as though all of the Lucent engineers had thrown their votes for Microlore, and that was a fair number of folks. No way to prove it. What wound up happening was Vic Hayes took that, looked at it, and said, Who
was a Lucent guy.
He's a Lucent guy.
But a straight shooter.
But he's a straight shooter, right? And actually part of the calculus here was knowing that Vic always wanted to be above board, right? Obviously they had huge market power, but he never wanted to be seen as leveraging that power. And so he was going to do this right. And what wound up happening was they had to, recess, figure out what to do. I think the very step of taking the recess through the mechanics and the logistics of the meeting off, so that there was no way to actually get another vote in to decide the technology at that meeting in the Netherlands, which probably meant that Intersil was going to win the vote at the next meeting, which was going to be in Texas. But something very, something that you'd hope would happen actually did happen, which was the Intersil guys, the Microlore guys, and the Lucent guys got together and said, is there a combination, or is there something that we can do to make this acceptable to all three? And they changed the modulation scheme that Intersil had proposed, which was, I think it was called MBOC, and I don't remember what that was for, and they overlaid the technology that had been proposed by, I don't remember whether it was Microlore or Lucent, to what ultimately became the CCK that is in the 802.11b standard. And that was what got proposed at the next meeting in Texas, it flew through, with overwhelmingly, and that was it.
And it was something that supposedly was an easy change for Intersil to make in their silicon.
That's right.
That allowed them to have their time to market advantage, and in your situation and mine, to
yes.
help 3Com with that partnership.
That's correct. That's correct. It was a little bit of a delay from what they had, but not so much of a delay that it was going to cause a problem.
Right. Right.
And what gave you the idea of the block voting? Were you very familiar with Robert's Rules of Order already, or what gave you that inspiration to look for that?
So we were, and Jim Zirin was the kind of the lead guy at Intersil, who's very familiar with the Robert's Rules, the politics. He and I had talked about, what are the things that can or might happen, and what can we potentially do if they do.
And if I remember, you were running around at breakfasts and lunches and polling people as well, and sort of doing your own. It was like a political election where they're doing surveys to figure out where the vote's going to end before the actual election happens.
Absolutely, positively, right. And then the question is, okay, if this happens, what do we do? If that happens, what do we do? And so there was a lot of time researching Robert's Rules, right, during the breaks or during the voting itself, which can get pretty monotonous, to try and figure out, okay, well, what can be done here to help either move this along or slow it down.
Jeff, so we've talked a little bit about your experience with 3Com and how you started the Wi-Fi Alliance. And then with all of this, here you are, you founded the Wi-Fi Alliance, you got that thing going, and it's got momentum, and you leave 3Com in the middle of this. So what happened there? What made you give up on 3Com, and what was your next step?
Well, great question. And I'm going to go back to a story we were just talking about off camera. When we stopped the internal 3Com product, I had gone to Doug Sprang, who was president of Cellnet and division general manager for the adapter division, and I said, wireless networking is still going to happen. That what we have is not a failure of vision, but of execution. I thought 3Com could be successful pushing forward the high-speed version of the standard. And 3Com had a very rigorous milestone process, and this was that milestone meeting, and this was the decision, and Doug looked at me and said, well, I understand. I admire your perseverance. I wouldn't do this if I were you, but if you really want to, go ahead.
This being? This being
a high-speed version, pursuing additional 3Com energy into a high-speed wireless LAN.
So this is the symbol deal.
This ultimately became the symbol. Right. This was the we had tested out whether it was possible.
Yeah.
So we had some idea that we could do it, but it was really pursuing it in earnest. So that was kind of the go-ahead, if you will, to go and really, ultimately the Wi-Fi Alliance and all the 802.11b products and the future of what 3Com did, which wasn't that great, but really the future of what the industry did. So there was this kind of, at that point, a big step back from 3Com's perspective on what had been a large initiative to a much more of a kind of let's see what happens. And
so the symbol Intersil was more opportunistic.
It was more opportunistic.
Doing our own from the silicon up. It was more partnering and
exactly. Yeah. And not to say that there was. I think when we came back and showed what we could do, there was definitely support for it. But it didn't have the same tenor as what had happened earlier, and obviously we didn't have the internal engineering team. And at the same time, the industry was truly making great progress. And the truth is, 3Com was helping to drive it, right? The Wi-Fi Alliance was a seminal moment in the history of the industry. And I gave a talk at a local, the Wireless Communications Alliance in Silicon Valley towards the end of '99 on the state of the industry. And wearing my hat, my WLANA president hat, it said, is 2000 the year of the wireless LAN? And in 1999, there were about 1 million nodes of wireless networking sold. And in 2000, there were 5 million nodes. A 5-fold growth of the market is pretty extraordinary. Or that really was the knee of the curve, and the industry's never looked back. I mean, if you look back, the trajectory since then has just been remarkable.
So I have to inject a little anecdote here.
Yeah.
So when I joined 3Com
Yes.
in 1989, the company celebrated their 10th anniversary, and within a month or two, celebrated shipping their 1 millionth unit.
Yeah.
So it took 3Com 10 years to ship 1 million
Yeah.
Ethernets, and now you went from,
the industry,
the wireless industry went from 1 million to 5 million wireless Ethernets from 99 to 2000.
Right, so that was that was on the back of this high rate, right? It started to become exactly what folks had forecasted would become 5 years earlier, and 3Com, who had all the vision, no longer had kind of the stomach to do the level of investment that other folks were doing. So, you know, Cisco bought Aeronet for $800 million in, I want to say, October of '99, and you know, we talked about the Microsoft deployment and other folks. Intel was now working in earnest on. Now they're working on a number of different wireless efforts, but Apple was including Wi-Fi in their MacBooks. So the industry was truly on a ramp up, and there were all these you know, smaller companies looking to take advantage of the growth of the industry. I left for No Wires Needed because we had identified them as a potential technology partner to bring us lower cost solutions in the future and to deliver on high-speed solutions in the future.
So what did they make? A lower cost solution for what?
Their core technology was a high-speed Mac. They built medium access. They built the 802.11 medium access controller on
it was
an
a
ARM
software company.
It was, well, the core technology was a software because they built a Mac on an ARM processor, but they actually had worked with an ODM in Taiwan and built a end-to-end solution. They were the first company to actually introduce an 11 megabit solution in the market. It turns out it was based on MBOC, the Intersil technology.
So it was using Intersil's radio chips.
It was using Intersil's radio chips and their own Mac.
So they were competing with their partner in a way, because Intersil had their own Mac as well?
Intersil did have their own Mac. They had bought Choice way back when, because Harris was essentially a radio company, and they really didn't understand Mac. So first they bought Choice. I mean, this is probably deeper history than may be interesting, but they had bought Choice Microsystems, I want to say mid-94, 95, so that they would have a full chipset. And that, that technology was somewhat questionable. Then they wound up buying a company called Intalk, which was a spin-out of Symbionics. Symbionics had been another contributor to 802.11. A couple guys saw the Wi-Fi was starting to happen, John Edney and Simon Black. So they formed this company, Intalk. They started building a solution, and they actually got some adoption from Nokia, and Intersil wanted to get Nokia as a customer. Actually, that winds up being important in the Wi-Fi Alliance story, because the sixth vendor in the Wi-Fi Alliance was Nokia, because Jim Zirin had this connection with Nokia. So, so they actually had two Macs, but ultimately they were going to need a high-speed Mac as well. And so I went from 3Com to No Wires Needed, knowing that the industry, knowing, by the way, that the Choice Mac was limited in terms of speed it could support.
On a state-of-the-art ARM processor at the time.
That's on a state-of-the-art ARM processor at the time. And so,
Jeff, just to put this in some context,
yeah.
How many chips were in a Wi-Fi solution? Because we think of it today as one chip, right?
Right.
But there were
Great
multiple
question.
RF and separate SAW filters and MAC chips.
Yes, I would say in the first Intersil chipset, I think for 802.11b, I may be off by a little bit, but it was really 5 chips.
Okay.
Right. And so we're about to get, it's about to get collapsed to 2. That's part of what happens here in 2000, 2001, 2002 is the number of chips, the cost of the chipsets come down dramatically as the number of devices shipped goes up, right? People are taking advantage of the investment in technology to really drive performance up, drive costs down, and drive integration.
And what were the 5 and what were the 2?
Oh, I'm not going to remember.
Okay.
the architecture, the specific architecture. But typically, obviously you have a separate MAC and a separate radio and a separate amplifier. But the early chipsets had
an intermediate frequency, so there was a high frequency radio and a low frequency radio, right? And there were some SAW filters in between, which I don't even think are in the 5 chip count. I think the filters were
It may have been external. Yeah.
Right. Yeah.
So, yeah, it was a lot of integration happening. And one of the trends that people talked about, so now in the 2000, well, no, this is when so I left and went to No Wires Needed. You left 3Com and went to Atheros, right? And Atheros was doing CMOS radios, right? And so the opportunity there was really to change the game from a front end perspective.
So talk about CMOS versus what was Intersil and Lucent doing before CMOS.
There was a variety of analog approaches to radios that I'm not going to recall.
They were silicon germanium and gallium arsenide, much more expensive.
And right, not only were they more expensive, but they were not going to be able to ride a cost curve.
Or integration.
Or integration.
Right.
So, yeah, and I'll just put a little bullet point here. I talked about a $50 chipset, or maybe I talked it off camera. An 802.11b chipset in 1998, 1999 timeframe was about $50 for the whole chipset. That chipset now is one chip, and it's less than $1, right? At 50 times performance.
Yeah, I remember my Atheros days. The prices were coming down 20% quarter over quarter.
Yeah,
which was incredible pressure on us to cost reduce and integrate.
Right, when we did the original.
Did the same thing in your Broadcom days.
That's exactly right, and it was a dynamic that Intersil was not prepared for, but we're getting ahead of ourselves.
Yeah.
But
well, go ahead. Finish that thought. Because
Yeah.
we're talking about the chips and how
Yes.
the chipset's integrated, and
Yeah.
and so some of the players got left behind with
Yes.
this
So
transition to CMOS away from gas and
exactly, and it really
silicon
opened up
germanium.
the whole new competitive playing field, right? It was really in 2000. So in 2000, by 2002, 2003, you had Atheros pushing CMOS and 5 gigahertz. Broadcom really hadn't made themselves visible, but they had bought an HPNA company called Epigram and had converted that team to work on Wi-Fi. And the reason they brought me in is they didn't have any Wi-Fi guys. They were a little unclear in terms of what they were developing. I'll just jump ahead and talk about
well,
it.
hit the high level, because we'll come back and dive into that in more detail, but just talk about the sort of chip roadmap, and then we'll come back to your Broadcom experience.
Yeah. Well, so the chip roadmap said we're going to go from these analog plus MAC Wi-Fi solutions that are 10 megabits or 11 megabits, and we're going to go to digital radios and integrated solutions that are 54 megabits and greater and capable of riding down a pretty steep cost curve.
Which they've done to this day, as you point out.
Right.
All right, so let's jump back. So you leave 3Com and you go to No Wires Needed. Why did you leave, and why did you go to where you went?
Well, I went to an opportunity that just seemed too good to pass up, and this is the .com days. They had technology. We had vetted the technology, so I knew they had what they said they had.
So this was they had a high-speed Mac.
They had a high-speed Mac.
Was really able to do 11B performance?
No, people could do 11B. They couldn't do 11A. They couldn't do 54 megabits.
Okay, got it.
And by that time, people were talking about G, although nobody knew whether G was going to be real. But it was clear that
G was illegal at the time you left 3Com.
Right,
you couldn't do OFDM at 2.4 gig.
No, but the Standards Committee had started to talk about 802.11g. So what happens again? G was founded the minute 802.11b was finished. Then you can propose a higher speed extension, and so G got proposed in the committee. And then the question is, well, what was actually going to happen? But the communications industry, everyone was familiar with what happened with the modem wars, where you introduce a new technology, and if you can leapfrog somebody else, you're going to get somebody to buy your product. And if you can do it at lower, without an incremental or a significant incremental price increase, then then that's obviously good. So there was already some momentum around 802.11g. There was, is it going to be A? Most people thought it was going to be, the next thing coming was 802.11a. But it really didn't matter.
C, D, E, F.
Oh, what happened, each different initiative will have a different letter. So E, for example, wound up being, it was originally both security and QoS, and then they split it. And
quality of service.
Quality of service, and they made I security. But then if you have a cleanup task force, that'll get a letter as well. So the letters fill up pretty quickly.
But some of those got sucked into
ultimately
G and B.
That's
right?
exactly right. So what'll happen is, by the time N came around, they sucked up a whole bunch of letters, and N had the whole smorgasbord included in the spec. You really have to pay attention to know what you needed or didn't need, and of course the semiconductor vendors did, but the end customers, of course, did not need to. But it made for progress in parallel, in some sense, within the IEEE. So, No Wires Needed looked like it was going to be an up-and-coming startup. It was based out of the Netherlands. And the interesting story there.
Were these ex-Lucent guys?
That's a great question. The answer is that this was a bunch of really bright guys who, for their senior project at Enschede, they had gone to the IEEE meeting that had happened at Enschede, and so had gotten interested in Wi-Fi. Maybe they got interested before that, but they took the challenge to build an 802.11 Mac on an ARM processor. And then, I don't know the exact dynamics, they pulled in other guys, but essentially, not only did they build the 802.11 Mac, but then they built then they finished school, I think they all finished school, and they built an entire product around it. So.
And had the best one in the industry.
Well, they had the best Mac. The product itself.
Fair enough. Yeah.
But they sold it. And there's an interesting dynamic too. And there's just all this rich tapestry of things going on in the wireless industry at this point. You've got ecosystem players looking to do software, looking to do hotspots, looking to do add-on software. So the Taiwanese government is giving manufacturers money to build Wi-Fi product. One vendor, or one ODM called Gemtech was a small player. They had partnered with this company I mentioned before, Intalk, to build their access points. Intersil bought Intalk. Gemtech had nobody's product to build. No Wires Needed came in and took that open slot, right, and started building product at Gemtech, which turned out to be fortuitous as well. Gemtech ultimately, at some point in time, winds up being the number 2 ODM in Wi-Fi. They just became Wi-Fi experts. So I was there for this kind of rough and tumble market expansion in No Wires Needed, and 3 months after I was there, we got the first offer to buy the company, and we went to the board and said, wait, we're not ready to be bought yet. Give us a couple more months, and then ultimately, a couple months later, Intersil came back with an offer that No Wires Needed could not refuse.
It was like
$154 million to buy essentially Mac technology.
Which, given the revenue of the company at the time,
was a pretty sweet multiple.
What was the revenue? It was single digit.
It was actually it was probably somewhere between 10 and 20, if I remember correctly.
Okay.
Yeah, because it was systems. Mostly what we sold were wireless LAN systems, and we had a proprietary security technology called Airlock, which was kind of cool, because we knew that there was a problem with WEP in the original 802.11 spec.
So let's come back to security. So finish this, because I do want to talk about security and how that played in and how that played into the Wi-Fi alliance as well.
Yeah.
But so when you're at No Wires Needed, are you still involved in the Wi-Fi alliance?
We became a Wi-Fi alliance member,
but not a voting member.
I was certainly not a voting member, and which winds up important, right? For the voting members in the Wi-Fi alliance have all the power. The regular members can only influence by going and influencing the voting members. Even the director doesn't necessarily have a vote, right? They have influence, but the voting board members hold the power in the Wi-Fi lines. So the answer is I'm viewing it, but things were so crazy that right, didn't quite matter for us. We're just trying to sell the product and license the technology to as many people as we can. We did have a deal with 3Com. We had a deal. We were working on a deal with Compaq. You know, it was definitely exciting times. And then Intersil was growing. Again, the industry went from 1 to 5, and that was really Intersil's big growth year. I remember my first, so we got acquired by Intersil. I went to Interop. We were supposed to show our product by ourselves, but all of a sudden we were now part of Intersil as well. We're not really in the systems business. So I went to a meeting though as Intersil, and we had this parade of Intersil customers come and ask for chip allocation because Intersil could not build the product fast enough, and we couldn't foresee a time where we could get out from under, you know, having quotas for customers. So it was kind of this very interesting time in the wireless networking space.
And what was your position
at Intersil?
No, well, first.
Oh, so
at No
Wires Needed, I was the vice president of marketing. So I ran all of product management and business development, and we started the U.S. office in my garage, but ultimately we got a facility in Menlo Park.
So you stayed here?
I stayed here, and I traveled to the Netherlands every 3 weeks.
Right. And then you get acquired, and
so we get acquired, and now my headquarters is in Palm Bay, Florida.
Right.
I was the head of the wireless LAN business to the consumer. Right. So at this point, wireless had started, we talked about this earlier, it started, you know, in the early 90s as a completely vertical market. And as the standard got finalized, and particularly as 802.11b became finalized, you reached Ethernet speeds, it started to go more mainstream. And the mainstream that it went was the enterprise. So Microsoft did a deployment. Once Cisco bought Aeronet, they were looking for mainstream deployments. But there was always this expectation that you could have wireless connectivity in the home.
Right, because this is when cable modems and DSL started rolling out,
that's
and we
exactly
went faster than our dial-up modems.
Right,
and
so now you had broadband, and the question is, well, how are you going to distribute the broadband in the home? And Wi-Fi was the perfect solution. Home RF would say they were the perfect solution, but Wi-Fi was the same standard that was in the enterprise. So you could have your laptop connect in the enterprise, take it home, go anywhere in the house, and stay connected. Seemed like a pretty good, compelling vision.
So you were running that for Intersil.
So my job was to try and figure out, okay, how do we do this? And you know, the Intersil was big enough where we actually had multiple product teams. There was one team doing 802.11a, and that was thought to be the enterprise group. And B was obviously already enterprise, but the question was, you know, what does the consumer really need? And G seemed like the perfect answer. And I had actually brought in a team from Anderson, the follow-on team to the Carl Temme team.
Who had done the work at 3Com.
Who had done the work at 3Com that we talked about earlier. And we did this project and said, yeah, you know, G looks like the right home solution. I went, we actually pitched it to, I remember pitching it to Dell, we pitched it to Apple. It didn't quite have priority at Intersil, but it was moving along. And things looked like, you know, the world was just going to be the oyster for Intersil, because there really was not any competition from a chipset perspective. There was a potential that TI was going to have chips, and I guess they bought Elantra, they came in with a chipset, they had this proposal in 802.11g, but all Intersil had to do was execute, and you know, they were off to the races. Then the big guys kind of decided that wireless looks like it's a pretty attractive opportunity, and Marvell, Broadcom had already been, you know, sniffing in the standards bodies, and you had a startup like Atheros who was exploring CMOS into the Wi-Fi space, and so
So you saw the handwriting on the wall there at Intersil?
In essence, yes.
How long did you stay then at Intersil?
I was at Intersil a year.
Okay.
I left actually for personal reasons. My mom was ill and subsequently passed away, but I also knew I was leaving. And after a little bit, not very much time, I wound up first getting recruited by Marvell. I didn't go there, and I wound up going to Broadcom. And the pitch.
So you went to Broadcom next, and you went to Azimuth later. Is that
That's
right?
correct.
Okay.
Yeah. So the pitch from Jeff Thurman, another former 3-commer, he was at Epigram. Epigram sold to Broadcom for
just to paint some background. Epigram was originally in
HPNA space.
HPNA, which was a home phone network alliance. So it was home phone.
That's right.
Networking for home.
Right. So the idea
didn't
here
catch on very much. So
right. So but the notion. The idea still was, okay, broadband's going to come to the home. How are we going to disseminate within the home? HPNA was this industry association. Epigram was the leader in HPNA. Broadcom bought them, realized...
Broadcom being the leader in cable modem chipsets. So they brought the data into the home, and they wanted to distribute it in the home.
That's correct.
Yeah.
So, so they bought Epigram, realized that HPNA was not the technology of the future, thought Wi-Fi was the technology of the future, turned the team towards Wi-Fi. They happened to have one of the original 802.11 Mac architects at Epigram, Matt Fisher. And so that was probably helpful in the design. And then they came after me. They actually found me at I think it was a Comdex panel that I was on. It was a Wi-Fi versus home RF panel. And for me, the writing, I mean, it was clear this is late 2001 that Wi-Fi was going to win, but there were still some, Intel had invested, Motorola had invested in home RF. You still had some.
Which was Proxim's technology.
It was Proxim's technology, and you had this sense that it might still happen, but I was pretty aggressive on the panel, which suited Broadcom well. So they wanted to hire me to help drive their aggressive wireless LAN efforts. They had nothing in this. They had no market share when I joined, but Jeff Thurman pitched to me that their product cycles were 9 months. So they're doing new chips every 9 months. And yes, they had not started on 802.11g. And in fact, I don't think they had started on 802.11a in earnest. They had done some work on a B chip, but he showed that but he basically had this sense that he was going to catch Intersil, because externally they thought Intersil was doing new chipsets every 2 years. And I knew Intersil was trying to do chipsets every 18 months and probably every 2 years. So I looked at it and said, wow, right, if you can really iterate on a 9-month cycle, that's going to be huge. Joined Broadcom, and I had actually not officially joined. I had not stepped foot in the office when I had my first seminal meeting at Broadcom. I'm on vacation, so I signed on the dotted line, and then I went on a Christmas vacation. I'm at my family's home, East Coast, and I get a call from Jeff Thurman. They had just pitched Apple on 802.11a, and Apple said, we don't want A, we think we want G. So the question was, Jeff, what do you know about G? And our engineers think A is going to be better than G. Should we do G?
Now, Apple was already shipping B at this time.
That's exactly
right.
Which
Case Links back at Lucent provided, right?
That's correct.
Okay, so they're already in the B, but they want to go to G.
They're in the B, but they want to do higher speed, and they want to do it at a affordable cost. And the thought was that A was not backwards compatible.
Because it's in a different frequency band.
It's at a different frequency. Say A is 5 gigahertz and B is 2.4 gigahertz. G was going to be the high-speed extension of B. So, so Apple didn't want to go with the dual band. They wanted to be cost-effective, and they gave that feedback to Broadcom. And I think at the time, Apple was probably thinking they were going to Intersil.
Was this Art Astron at Apple you were dealing with?
I don't remember who. I mean,
he did the original
B. I think that could be.
He was still there in G.
Yeah, I'm not going to remember. No, because I wasn't in the Broadcom meeting.
Yeah,
right?
yeah.
I wasn't there yet. So what happened was we had this meeting, and I'm on the phone. It was like a 2-hour knockdown, drag-out meeting, and Jeff and I was advocating for G, and so Jeff said, "Okay, we're going to go back and talk to Apple about." I had the team dummy up a G proposal. I came back, and I wouldn't say we spent the next month in debate, and we had this war room that had stuff all over the board, right? Market size, chip prices, potential customers, industry segments, and how this industry was going to break down. At the end of the day, we said, okay, we're all in on 802.11g, and we're not going to tell anybody. And so our AB chip became a G chip. Now, so just architecturally, this is kind of interesting. So again, 802.11b is 2.4, 802.11a is 5 gigahertz. It was thought to do a dual band chip, you have to have a complete MAC and PHY for the 2.4 and for the 5 gigahertz. So that's the chip. You do it in one
chip, but it's basically 2 chips in one.
It's basically 2 chips.
The whole radio changes.
Right.
Different.
And the 5 gigahertz has the OFDM PHY. So here's what we wound up doing, was taking that chip. So rather than design a new chip, and the chip was pretty far along, we basically just didn't use the second MAC.
Radio.
Oh no, we didn't use the 5 gigahertz radio, and we didn't use the 5 gigahertz radio was external, okay. And we didn't use the second MAC. We just said, you know what, we're going to go to market with a higher cost solution, and we're going to just depend on time to market. And we priced forward, and we lined up Apple, we lined up Linksys, and I tried to line up Dell. I got thrown out more than once, and then. I'm missing one.
You got Netgear.
Ultimately, we got Netgear, but the original was Apple. Linksys. Oh, it was Dell. We thought we were going to get Dell. Dell wanted AB because Intel had convinced them that they wanted AB, right. And we were thinking they were going to go to G ultimately, and ultimately they did. And then we had this incredible debate internally because we couldn't support all 3. How are we going to get? Anyway, the development effort continued. G ultimately got launched in March of 2003. It became just a ginormous hit. I remember the NPD numbers. NPD does market studies for retail sales. Showed that retail went 23% of the retail market went to G in the first quarter. So it was just an absolute rocket ship, and Broadcom went from 0 wireless LAN sales to $250 million in wireless LAN sales in 18 months. And we were having trouble keeping up with production. We were holding on by our fingertips. It was go, 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 go. It's very exciting.
And you and I went from being partners at Crime at 3Com to being arch competitors.
Arch enemies, right.
Because Atheros and Broadcom were the big 2 really in rolling out those chips.
Absolutely true. Yeah, Intersil had thought about, not thought about G, was planning G, and then had some mishaps. And you very cleverly, right, we're focused on A and realized, you know what, there's a market in G, we can get to G quickly.
Yeah, and the FCC changed the rules midstream, and we had to react.
Yeah.
Right.
Yeah. So, so that worked out well for you guys, obviously worked out well for Broadcom, and the market just completely shifted.
So I want to jump back to WECA because G presented an interesting challenge, or not WECA, but Wi-Fi Alliance.
It became the Wi-Fi Alliance.
Because the Wi-Fi Alliance was doing B interoperability.
Yes.
And then, I think the next thing was actually Atheros coming to the organization saying, will you certify A? And then G came along, and then there was a whole branding challenge of how do you do interoperability when you have this new gen and Bs don't speak G.
Right.
And so talk a little bit about that
well,
whole
actually,
transition.
I'll do a little interjection there too,
Yeah.
because I think the response of the Wi-Fi Alliance to A in particular was really important in the development of the whole industry. And Atheros' decision to leverage the Wi-Fi Alliance was key. Was a key part of that. So when we set up the Wi-Fi Alliance, we used the paperwork from the WLANA, which had followed the Ethernet what was originally the Ethernet Alliance, Fast Ethernet Alliance, Token Ring Alliance. So organizations, the interoperability organizations, tended to be around technologies, not about industries. And so if the Wi-Fi industry had followed the pattern of wired networking, 5 gigahertz might have had its own industry association. And instead, you chose to stay in the tent and get the seal of approval from the Wi-Fi Alliance. And I remember there was some tension there.
Yeah. Yeah, it was interesting because I think the Alliance felt it was the right thing to do.
Yes.
But the individual members like, well, we're not ready to ship it yet, so we want to drag our feet and slow this down.
Yes.
Right. So they embraced us, but with a foot dragging approach.
Right. And now at that point, I'm back in. I'm not on the Alliance board, but I'm tied into it because I was with Intersil,
right,
which was a founding member, and so. The thought was, well, it's IEEE, and we do want to do it. And then I remember there was a fear, well, we don't want Atheros or Intel to take 5 gigahertz elsewhere. Mm-hmm. But the fact that it stayed within the tent, I think, really is what helped move the industry forward. And so there were the conversations about how to do, and it was a little bit of a challenge. B and A, I think, were a little bit less of an issue than adding G, right? Okay, how are we going to create these interoperable logos so that people can look at the box and figure out this product works with this product, and should we have A only? No, we can't have A only. Everything has to be backwards compatible, et cetera, et cetera.
Well, one of the things I remember was that with 802.11a, the Alliance came back and said, well, to do interoperability, we really should have at least 2 chip vendors,
yes,
and multiple system vendors. And so we were actually hoping Broadcom would ship that 11A product that we knew you guys were working on, but you never ended up shipping until much later when you did an ABG.
That's right. It was a total head fake.
Right. So because it really held up our ability to get official certification for interoperability.
But how, with the 2 different bands, how did you do backward compatibility then?
So you had to have both. You had to have a radio and a chipset that did both.
But the logo, there was a logo design from the Wi-Fi Alliance that showed B and A.
Right.
And so they distinguished which things you were interoperable with,
right,
and that became important with A and G as well.
Right, and they were different colors. Right,
there was a lot of effort on that.
A lot of effort, what the colors were and what the logo was going to look like.
Because you didn't want the consumer to just see Wi-Fi
and get confused.
Interoperability and then have it not be.
Right. Yeah.
And 802.11a only products didn't ship for very long.
No.
So everything was backward compatible to B.
That's right.
And in fact, the Alliance never certified an A only.
No.
It had to be at least B compatible.
Correct.
So they never certified until there were A-B combo.
Yeah.
And then G was always A and B.
Well, G was always
G
and B and G.
Because if you did G, you kind of got B for free.
Yes.
True.
Well, that was our line. Yeah. Get G, B for free. The thing, by the way, the transition to 802.11g, what made it so palatable was because of the transition in technology, the G products were 5 times as fast, but the cost was basically the same. And vendors could actually introduce them at higher prices. They could pay the same cost for the chipset, introduce them at higher prices, market them more heavily, and so it was a huge profit motivator for Linksys, Netgear. I mean, Linksys basically built their business on that launch of 802.11g. They ultimately sold for $500 million to Cisco, based on the growth in that 802.11g business.
But talk about the chips a little bit, because one of the challenges for the old guys, the 11B guys and before,
Yes.
was getting their Macs to operate at 54 megabits because the ARM processor and the code didn't run fast enough. And this was...
Well, that's why Intersil bought No Wires. They ultimately, I think, and I don't actually have the details because then I left Intersil and I went to Broadcom, and I didn't really pay attention to Intersil's inability to keep up, but it became very clear that they were challenged. Right.
And,
they were
and
both
Broadcom
challenged.
and Atheros went to state machine Macs rather than
That's
software
correct.
running on an ARM, which
That's exactly
really
right.
eliminated that performance.
Yeah, the Choice Mac was actually a state machine Mac, but had some of its own performance limitations, which I'm not quite sure what they were.
Stuff. So let's jump back. Another sort of thread through all this was security, and you touched on it a little bit. So take us back to the beginning of the original Wi-Fi, and if you remember, everybody had some proprietary, and then WEP came along, and WEP was obviously broken.
Well, WEP was, so I actually remember the conversations in the IEEE meeting, the original IEEE meetings. I remember Dave Bagby was the chair of the security committee. And the
WEP
question,
stood for?
Wired Equivalent Privacy. So the notion was you could actually tap a wired line, right, and figure out what was going on. And so clearly the ultimate security was not what was required, and we needed to get something to market. And so that phraseology became adopted. As long as the security was good enough, there was this expectation that better security would come later. And it did, right? 802.11i was formed to do that, and AES encryption wound up getting built into 802.11i. In the meantime, there was this, and when Wi-Fi was not mainstream, people didn't have any incentive to go figure out if WEP could be broken. And I'm not going to remember the exact timing, but somebody broke WEP shortly after Wi-Fi started certifying products.
But if I remember correctly, the weakness in it was known, but because people were doing it on an ARM processor, it was kind of the best they could do without changing their fundamental architecture as well.
That may be true. Well, I think there would have been a political challenge in changing something within 802.11, and then there may have been an implementation challenge as well. But just getting standards through the Wi-Fi through 802.11 was non-trivial. So what wound up happening was, my recollection, the WEP got broken. The Wi-Fi Alliance actually, and David Cohen, who I mentioned earlier, wound up being the security chair and driving, after he was president, so he went from vice president to president, left 3Com, and then wound up, with me at Broadcom. I hired him at Broadcom. As the security chair. I skipped a step in between, but the Band-Aid was TKIP, where you would change the keys fast enough that it was tough to break the code. So that's one, and I think the industry is just lucky that it didn't blow up into a bigger deal in the time frame between when the original WEP products existed and when first the Band-Aid fix and then the real fix came out. But I'm sure Atheros did this, I know Broadcom did, is that our first G chipset actually had AES built in, right, which was called, so what happened was the original standard had just this WEP, wired equivalent privacy. The Wi-Fi Alliance came up, pushed on TKIP, which was rotating keys, and called it WPA, Wi-Fi protected access. And then once you added the AES encryption, then it became WPA2. And that was really what was advocated, if you will, for enterprise solutions. And that helped the technology move into mainstream as well.
Mm-hmm. Lots of moving parts going on.
Many moving parts with lots of different players. The semiconductor vendors at this point kind of settling out, right, where you now have a Broadcom, Atheros, Marvell world with you know, Intersil and TI kind of getting left out.
Right.
And Proxim, who had proposed all the technology for first open air and then home RF, getting completely sidelined. In fact, I think they went under. So the bets were big bets, and those who bet right did well, and those who bet wrong, I mean, you could bet wrong and lose everything.
And Lucent ended up acquired by Proxim, who were the whole old home RF guys.
That's exactly right. Before they went
bankrupt.
Right, they bought Lucent. Yeah. So that was right, and unfortunate. I mean, the industry's just started changing so much that it's sometimes hard. Right? I think that's a lesson in industry evolution, where you have the folks who really built the foundation and understand the technology, and then things start to move so fast that it's not, that part's not what's relevant. It's, well, what can you do on top of that?
So you talked a little bit about Cisco, one of the really big companies getting into it. You've talked about Apple a little bit too. The other 800-pound gorilla that got into this was Intel. Yeah. And their Centrino, which was a bundle of originally the graphics chip and the processor and Wi-Fi. And I remember talking with one editor who said, you know, now that the Wi-Fi is built into the processor, I said, it's not built in. But their marketing was so strong that people thought it was all in a single die, rather than being separate die, which they originally bought from TI. And doing it as a marketing bundle. They really misled the press on that. Talk about how you think Centrino and Apple and some of these other players influenced the industry. I mean, I've talked to people who felt like without Centrino it would have happened much, much slower. Other people give Apple the credit for making it happen quickly. What's your perspective on sort of the accelerators?
I think Intel was absolutely positively an accelerator. They invested a lot of money in a variety of different areas. I mean, they did some harm by also investing in home RF and in Bluetooth.
Early, though. And they had given it up by Centrino.
I think some of the Bluetooth stuff was still out there when they were still out there when they're doing Centrino.
Yeah.
But what was good for the industry as a whole about Intel was that they were spending dollars in a Wi-Fi direction, whether that was investing, I forgot what hotspot company they invested in. I mean, Intel Capital was investing in different players and building out the ecosystem. And they certainly caused a lot of, you know, consternation, obviously, at 3Com, as, you know, thinking about, well, how are we going to compete with them longer term? Broadcom, in terms of, well, how are we going to sell to the PC vendors? Atheros, same thing, right? It forced us to be on a very aggressive technology development cycle.
Because they were basically giving the Wi-Fi away for free.
They were giving the Wi-Fi away for free. That's
so how did you and Broadcom compete with that?
Well, the same way Atheros competed, staying a step ahead technology-wise. So what happened was Intel bet big on 802.11a. When they finally introduced Centrino, remember this, they introduced Centrino about the same time we introduced 802.11g. So you have Intel, you know, putting the brakes on. The big, huge message from the industry was, G's not certified yet, so don't go there, don't go there. And part of that was that Intel had finally gotten their wireless chipset out, and it was 802.11b. And here we were going to all the PC vendors, and then you were going to the PC vendors saying, hey, you can get this next generation technology, but you got to buy it from us. And Intel saying, well, you can have it from us in a year's time. So it really created this technology war, which, you know, at the end of the day is good for the industry. But that's really what we did. We tried to stay ahead. We tried to stay ahead with the core technology. Then we added range extensions. You guys added, I'll get into the 108, the Super G, and just that was brilliant, right? That strategy. We countered with our 125 high-speed mode, and Intel is just, you know, sitting there
with B.
With B.
But it was free. Free's hard to compete with.
It was hard to compete with, I think, on the low end, but for folks that wanted to differentiate on performance, for folks that wanted to keep up with Apple, right? You needed G or you needed A. And then people did look at, well, what's the performance of the solution that's embedded in the laptop? and competition. I mean, the other thing that happens with Wi-Fi that didn't happen in the Ethernet space is it's not just about the chipset. Now you have to worry about, well, what's the antenna that's embedded in a laptop, and how do you differentiate based on that? And so there were multiple levers, if you will, for vendors to potentially differentiate on. So.
And what percentage of the market was laptops in this era?
At that point in time, so I haven't defined a point in time. The industry, it's kind of interesting, right? Because in the 1999-2000 time frame, people are still putting in infrastructure. It's the executives that have Wi-Fi, right? It's not all of the laptops that have Wi-Fi. Home routers really started to happen. They started to happen in 2000 to some degree. That's some of the 1 to 5 growth. But the breakout, again, was with G in 2003 is when home Wi-Fi really started to happen. So I think Centrino was the switch where people said, I can't have a laptop without Wi-Fi, or at least without a Wi-Fi option. And that's probably when Wi-Fi and laptops started to become prevalent.
Yeah. And it started as PCMCIA cards, which were those
exactly
credit card size things that slid in the side of laptops at the time, and you had a little flip-up antenna, which often got broken off.
Yeah.
And actually, back at 3Com, we had developed something called Mini PCI, which was an internal standard daughter card for laptops. Yeah. And the interesting thing is, originally that was for modems and Ethernet, but very quickly we had to figure out how you put an antenna on that. Yeah. And the laptop guys didn't know RF, so one of the things I think Atheros and Broadcom did well
was go and talk to...
was educate them on RF and how to put an antenna in a laptop.
Yeah. Yeah, but that too was the notion of anything for the customer, right, which was part of the culture at Broadcom and part of the culture at Atheros. Intersil was a spin-off of Harris, which was a defense subcontractor. So there was kind of a different, right, wait, you want us to help you with your antenna?
We'll do a study and then charge you for it, right?
Wasn't quite the same, right? So again, the industry had shifted, and if you wanted to, what Broadcom did particularly well was say, okay, these are the applications that are going to be large. These are the customers that we think can reach those large applications, and we're going to do everything we can to make those customers successful. So at that point, mid 2000s, it's still it's cards, it's increasingly the routers, and it's starting to be phones. So in 2003, we did the first single chip Wi-Fi at Broadcom, which seemed like, oh wow, this is going to be great, and we actually put it in the Sony version of the Palm Pilot. It was going to be the first Palm Pilot with Wi-Fi connectivity, and unfortunately, I don't think that product ever came to market. And so, what looked like it was going to be, it was the harbinger of things to come, right? But it actually wasn't successful.
The Palm Trio, right?
No, the Palm.
Oh, with a real pilot.
The real pilot, yeah.
They did an OEM deal with Sony.
Yeah.
Okay.
Yeah. Which also was at 3Com back in the day.
That's right.
True.
Yeah. Great. So fill us in. So you left Broadcom then, and what caused that change?
Well, the biggest issue was that, again, this is a family issue. I'm from the East Coast. My wife's from the East Coast. My wife's father was not doing well, so she wanted to move east. And I actually sat down with you and had breakfast and told you I was thinking about leaving Broadcom. I wanted to move to the East Coast. And you said, well, I'm on the board of a company in Boston. So talk about coincidence, by the way. The CEO of Azimuth, Ray Cronin, and I had sat next to each other on a plane flight just a few months earlier. So he had told me about the company, and I had told him I didn't think there was a business in Wi-Fi test equipment. And he had told me why he thought there was, and you told me why they thought there was. And but so it seemed like a good opportunity for a couple of reasons. Broadcom used their equipment. I knew Atheros used their equipment. I knew Intel used their equipment. So all of them, and Apple used their equipment. And they were working on getting certified to automate the Wi-Fi Alliance test procedure, and obviously everybody was building Wi-Fi solutions, so automated testing for Wi-Fi seemed like a good idea. Cisco had their own proprietary technology to allow better performance between Cisco adapters and Cisco approved adapters, CCX adapters, and Cisco infrastructure. And we had automated the test for that, or Azimuth was at the time, I guess, working on that. So, so testing was not something that was really well understood in the wireless space, but had the potential. And I remember one of the observations was, well, the networking industry tests rigorously. The cellular industry tests rigorously. The Wi-Fi industry, as evidenced by what happened with some interoperability testing for 802.11g, well, the system vendors don't necessarily test that much. They
kind of
rely
rolling around on a cart in an office to see where you drop the connection.
And the other thing was there was tremendous reliance on the semiconductor vendors, which gave the semiconductor vendors a lot of power. But it just seemed like that dynamic might shift. So I went to go sell, promote testing. Oh, by the way, with 802.11n coming, and the dynamics in N were you had this one startup company, Ergo, that had their own proprietary MIMO technology out in the market well in advance of when the standard was even, close to being completed. Then you had competing standards within 802.11n. We can talk a little about that. But there really was a likelihood that N products were going to have a problem when they first came out. There was, the Wi-Fi Alliance was going to go as fast as they could to get approval of N products, but you knew that folks were going to try and jump the gun, particularly in the consumer space. And so the idea was Azimuth could be there to help provide equipment to really advance the industry faster. So ex post, it didn't happen. Vendors continued to rely on the semiconductor vendors to do their testing. I remember to hedge their bets, Netgear actually, they wanted to be first to market because they weren't first to market on G. So they bought chips from, I don't remember whether it was Atheros and Marvell or Broadcom. It was two different vendors. And they actually had two different product lines that didn't interoperate with each other. So Netgear had two products on the shelves that originally didn't work together. And we had anticipated that they might have a problem. We tried to sell them test equipment, and they would have none of it, right? And their story was, well, the semiconductor vendors will figure it out, or ultimately the Wi-Fi Alliance will take care of it, but we're not going to get in the business of actually testing our products.
That's called the low overhead model. It worked for them.
Yeah, it does.
That's great. Well,
and you cut that on
Azimuth is a good example of some of the ecosystem companies that were really popping up around this time as well. You mentioned before some of the point of presence, the Boingos and stuff like that. Were there others that kind of come to mind that popped up around this time and really?
There were mesh companies. There were, I remember Instant 802 was going to license open source access point code. Well, they changed to DeviceScape, right? And now they're actually successful mobile phone software company. Right. So that was a successful pivot. Boy, I don't know. The ones that were successful got purchased. So now I'll struggle to think of who.
There were the hotspot guys who did the hotels. There was the Metro Wi-Fi kind of guys. So quite a bit of explosion of Wi-Fi everywhere.
Well, I mean, once it became clear that Wi-Fi could be everywhere, people tried. I mean, and it's going on today. I mean, if you look at what's happening now with Wi-Fi, it's just remarkable. I mean, I talked about going from 1 million to 5 million chips in 2000. The other benchmark number I have is it was like 50 million chips by 2004, 2005. It's supposed to be 7 billion next year. And the market has just truly gone non-linear.
And I read somewhere that the crossover of Wi-Fi with Ethernet happened actually a year or two ago. It's more Wi-Fi chips now than Ethernet chips.
Yeah. So, I mean,
phenomenal.
ubiquity is the name of the game, and I think that's great for the consumer, right? Because now you have what the original vision was back in those back in the hype days of 1990 to 1995, where wireless is going to be everywhere. It is, right? And it's cheap, and
right.
And you can put it in devices in the home. You can put it in devices in the enterprise. You can now farm out the smarts of what needs to happen to the cloud. So you can bring down the costs of the nodes that are part of the infrastructure, and that increases the possibilities.
So that leads to your most recent venture, your own startup company. Why don't you talk a
Right.
little bit about that, how that got started, and,
Yeah, so
and the whole intersection of Wi-Fi and,
sure.
and the cloud.
Yeah, so this was another one. You know, I guess I have to talk at these events more often. So I was at an event for Azimuth talking about voice over IP, and I was already on my way out, but they asked me to do the talk, and I wound up meeting the director of business development for Xerox PARC, and they had some technology that was mesh networking technology that they thought might be valuable enough to start a company around, and they had a program called Startups at PARC. So he told me a little bit about it, and I said, I don't think it's going to work. He said, well, he wasn't actually asking me whether I thought it was going to work. He was asking me if I knew a vice president of engineering that they could hire. but he listened to me and he said, you know, can you come in and talk about why you think it won't work? So so we had the lunch, and they wound up hiring me first as a contractor to figure out, well, if our idea is not going to work, what might work? And we came up with a bunch of ideas. I wrote a business plan for the one that seemed to be the best one, and it involved taking the technology that PARC had developed in mesh, taking the technology that they'd done with regard to security and ease of use. They had a program called Network in a Box that had patents back from 2004 to make it possible to just ship a small business this will sound familiar because it's one of the dreams at 3Com, right? Just ship the small business a kit, they can unload it, and everything works. The PCs work, the networks work, etc. So, and then they had obviously some ease of use because PARC is known for that. So they liked the business plan I wrote. They hired me as an entrepreneur in residence. I hired a team. I went out to VCs like Foundation Capital. The original plan for the company that became PowerCloud was to do a full end-to-end hardware plus cloud solution to manage those infrastructure devices from the cloud. And it probably would have been successful, save for timing. We tried to get funding in October of 2008, originally just before the market crashed, but then after the market crashed. There was not a lot of money to be had. We wound up doing a pilot with a major service provider, coming back out, trying to get funding. That didn't work. And so I tried to sell this cloud managed networking technology to vendors in the space, and you can imagine
As a licensing.
as a licensing. Oh, no, actually sell what we had done.
Sell the company.
Sell the company.
Okay.
And people said cloud managed networking sounds really interesting. If you guys decide to license the technology, we're interested, but I don't think we want to buy the company. I took that feedback and rewrote the business plan to basically sell software to hardware vendors. Struck a deal with Zycel, with first D-Link, then Zycel, then a small company out of Canada, and got funded as a software company to do cloud managed networking to small business. Now, ultimately, Meraki, which had started as a mesh networking company, added cloud, did the cloud managed networking, and got bought by Cisco for $1.2 billion. So we should come back and talk a little bit about Cisco in the market, because they've done an admirable job of acquiring, strategic acquiring in the direction that they thought the market was going, and calling it right. And I think they did with Meraki, and it's worked out well for them. For PowerCloud, so we did cloud managed networking for business. we were looking for larger customers. Larger customers, by and large, wanted to do things themselves. We pivoted. We wound up taking our solution. This is actually interesting in terms of where the market is headed. And we built a consumer router that allowed visibility and control in the home better than anybody out there. We did a Kickstarter project to prove to our investors that this was a product that people wanted. And
this was the SkyDog product?
So SkyDog was a successful, top 1% of Kickstarter ventures, and then we launched it on Amazon and wound up out of 3,600 routers you could buy on Amazon. We were the highest rated dual band and the second highest rated router overall before Comcast bought the company, with the goal of taking the features and functionality in SkyDog and taking the platform and being able to deliver that to their larger customer base.
Interesting, because Comcast originally said, look, we're going to bring the cable to your home, and we're drawing the line there. We're not getting into the home distribution side. I remember having meetings with the Cable Labs folks, and the whole industry said, hard line here, we're not going there. We're not going to be responsible for RF interference in somebody's home and trying to support that. Right. It sounds like Comcast is really changed their mind on that.
I think the whole...
Can you talk about that?
Sure. I think the industry's changed its mind, right? Yeah. The recognition is that wireless connectivity is what the end customer wants. Right? I would go all the way back to the studies in 1994. People would prefer to be wired versus unwired. They prefer to be unwired. In some places, there's no other way to do it, right? Your mobile phone's not going to have a cable connector. Right? And they're looking for ways to provide features and functionality to their customers that are going to make them sticky. And Wi-Fi increasingly is a way to do that. And then, becomes a little bit less about the core technology and a little bit more about what sits on top of that technology, the software to make things easier to use for the end customer, the software that makes it easier for the guys back at the head end to manage the whole system. And so, again, back to this ecosystem notion where now it's not just the chip vendors that are making money, but it's the software vendors that are selling management solutions or cloud management solutions to make the products better and more effective.
So big changes there.
Yeah.
So you mentioned the 7 billion number. I mean, that's probably a good question to close on. With,
yes.
The changes happening in the industry today with Comcast getting into the business now and trying to put it in everybody's home, whether they want it or not, because it's going to be bundled with the cable modem.
Yeah.
And the 7 billion number, it's in all our cell phone handsets. Where do you see it going? I mean, what other Internet of Things get you excited?
Absolutely. No, I think
specific areas there, because that's sort of a catch-all phrase.
It is a catch-all.
Right?
Anything that's connected to the Internet is an Internet of Things, and which is really true. But that is where it's headed, and Wi-Fi as a true connectivity standard that has been driven down in cost, and by the way, people have come up with low power versions of Wi-Fi as well. It's still, interoperable. So what you now have is this technology that can be embedded in everything from refrigerators to cars to coffee machines to obviously Nest thermostats, and people can, to the extent that they want to, right, control different aspects of their life by having the connectivity in their home, outside the home, and then have it all visible on their cell phone.
So the Internet of Things, though, can be, like you said, anything connected to the Internet. It can be connected cellular, it can be connected Bluetooth.
Yeah.
Zigbee another one that sort of has associated themselves with Internet of Things.
Sure.
Right, particularly in the home. Who's the big winner? Is it Wi-Fi? Is it all of the above? Is it going to fragment some? I think by different types of applications.
So I think I think the main winner is actually Wi-Fi. I think that the infrastructure is there, the big players are there. The key problems, the power would be the key, delimiter. If you can't get truly low power in the device, then maybe an alternate technology winds up having its own niche in the market. But people aren't going to put that anything other than Wi-Fi. Well, Bluetooth for the headset, obviously, but Wi-Fi in cars as an example. or in a refrigerator or in a coffee maker. It just it makes too much sense to build that in, and again, there's so much infrastructure to support that. Whether it's the vendors who can show these guys how to make it happen, or the taking of the information all the way back to the cloud and being able to tie that in with other information, with other devices that are in the house. I think the Wi-Fi industry really is poised to take the maximum advantage of it.
And any wireless protocol has its trade-offs, right? And when Wi-Fi tends to get picked on by its competitors is too high power. People always want it faster, right? There's trade-offs between range and distance and power. But power tends to be where it gets hammered most there. Some with ease of use. The whole BSSID thing is not real user friendly. Security, I think, has been an issue. It's less of an issue now, but still comes up. Any of these that you see as real limiting, or you think?
I think they are.
The IEEE and all will fix these.
Not necessarily the IEEE, but I'm now independent. I'm talking to companies. I know you talk to companies too, and I see folks understand where the gaps are, and there's enough of a market, enough of an opportunity for folks to figure out technical solutions or business solutions to fill those gaps. So I'm confident that that will happen. It may take time, it may take longer time than you or I would like, but I think ease of use issues can be dealt with. I think security issues can be dealt with. I think the speed at this point is adequate for just about anything people can come up with. And so I think it's still the golden age of Wi-Fi.
Great. It's interesting. A few years ago, one of the things you would hear is mobile first for applications, right? Because initially applications were developed for PCs, and then the mobile application was an afterthought, porting. And then there was this big trend to mobile first, where people would develop the mobile application and then maybe later do the PC version. We're starting to hear this phrase, Wi-Fi first. That your cellular phone will be Wi-Fi connected first and cellular second. Any thoughts? Is that really going to happen, or is Wi-Fi going to be so ubiquitous that cellular becomes less important or less necessary?
Well, for cable providers, for some service providers, the answer is an absolute yes. For the guys with mobile infrastructure, they probably want the Wi-Fi for offloading, but they don't necessarily want Wi-Fi to be first. So I'm not sure who wins in that big war, but there's no question that every phone has Wi-Fi or needs to have Wi-Fi in this day and age. So,
and that's a lot of phones.
That's an awful lot of phones.
Close to half your 7 billion. Great.
Ad hoc networking has been sort of in the wings for many years, and can you talk? I know that's possible with Wi-Fi, correct?
Yes.
But where do you see that going, if anywhere?
So I know I've actually done it, and I don't. It's not something that I necessarily track in too much detail, because I think that it's an application that folks will figure out how to do based on the silicon that's out there. I think it's a user issue that can get solved over time based on the application that people want to do.
Great. Any other thoughts for where Wi-Fi goes in the future? Anything that you see as compelling
you're going to see, obviously, cloud started a cloud-managed networking company. I think you're going to see more and more leveraging the cloud. Not that you won't still have, you have to have device on premise. So, enterprise will still likely have a hybrid, and you'll always have something in the home. But increasingly, you're going to take advantage of the processing power of the cloud, the ability to generate, ease of use, the ability to be mobile in your knowledge of what's going on with whatever device is connected. So, I just see more and more clever uses and applications of Wi-Fi in the future.
Great. So, go ahead.
Well, I was going to say the other thing that's, you know, it's just really remarkable. The industry as a whole, right, has just grown tremendously. As I was thinking about this interview, you know, you look back over time and say, wow, right, how did we get here? And it's fascinating. We wouldn't be here without the standard, obviously. We wouldn't be here without the Wi-Fi Alliance, because you really needed that interoperability testing. But then it's not just about organizations, it's actually about the people that really made things happen in those organizations. And you look back and you say, you know, it's interesting that a lot of people in the Wi-Fi industry have recirculated over time. And they are smart people, they are good people. They tend to be quirky, particularly early on. But it's been a great industry from the standpoint of people seeing the vision, you know, grabbing onto it and wanting to be part of it, wanting to advance the industry. So you really have just, in retrospect, kind of an ideal mix of the standards body, by the way, even the FCC have the standards bodies, the government organizations, the marketing or, you know, business organizations, the people kind of pushing it, and then good old-fashioned capitalism, right, thrown on top, where people realize that maybe expanding the pie, at the end of the day, expanding the pie and getting a bigger piece of that pie is better than trying to own our own smaller pie, right? And I think if you think back in the early days, everybody wanted their own little chunk, and what's actually wound up happening is probably the best possible outcome, where you do have this industry standard, you do have folks all working towards that common goal, and great things have resulted.
Mm-hmm. Any other, you mentioned FCC and futures, anything like 60 gigahertz get you excited? New unlicensed spectrum that
so I haven't,
Wi-Fi Alliance is adopting?
I have not had the time to spend energy there yet.
Yeah, great.
Yeah.
So how about for Jeff Abramowitz? What's next for you? Are you gonna, you've been a Wi-Fi guy since the early days.
Yeah,
hard to try to stay in that? Or?
Hard to believe that I wouldn't stay connected. In the near term, I am working with the Center for Entrepreneurial Studies at Stanford, and actually lecturing back at my original alma mater, Penn, in the entrepreneurship course there. But then I'm working with, boy, at this point it's probably 8 to 10 different companies that are in various stages and just trying to figure out, well, what's the next big thing, and, you know, how can I potentially help?
Great. So Jeff, let's talk a little bit about the applications over time. In the early days of Wi-Fi, you know, when it was Symbol and Proxim and some of these guys, you know, what were the applications? Who were the customers for this? What were they doing?
Mostly vertical market opportunities, right? You
like
put,
what kind of vertical?
Everything, inventory management, right? Trying to put something in a warehouse and having some basic tracking capability, or I remember NCR was actually wireless cash registers, I think was where they were headed. Manufacturing floors, just trying to figure out with things that were high value and wanted to stay connected to what the devices were, or some information from those devices. I think it was much more, again, vertical market. It was completely vertical market driven. I know early on NCR tried to do, or maybe did, a deployment at Carnegie Mellon as part of a push in education, kind of, you know, how could this be mainstream? But the adapters, even most of the adapters were desktop adapters, and the mobile adapters would have this big device, right? So you had big bulky laptops, and you'd have to attach not just a PCMCIA card, but a PCMCIA card to a radio, external radio. So really early stuff was mostly fixed, like on the manufacturing floor. And then as you could build those antennas, et cetera, into the barcode scanners, then Symbol was able to take advantage of that, or Proxim or Intermec were able to take advantage of that. So, you know, that was the 93, 94, 95 time frame.
And then Proxim got into the using Wi-Fi and proprietary radios across the street. It was sort of a
Yeah, there was a
a campus connectivity, more of a router type of thing,
or
rather than a
really point-to-point wireless.
Yeah.
That's actually, I didn't go into this, but that was the bulk of No Wires Needed's business, was actually point-to-point, basically taking an access point, pointing at another access point in order to connect two different buildings. It's never really been a huge business. It's always been large enough to make money and cheap enough to be worthwhile. But it's not really considered Wi-Fi because it's not really point-to-multipoint. People just use Wi-Fi because that's the cheapest technology available. So then, in the late 90s, laptop computers rose significantly, right? The application really became connectivity to corporate infrastructure primarily for business purposes. But then, as you mentioned, right, as broadband came to the home, and they came to a specific part in the home, how do you share that internet access with everybody in the home, whether it's a wired or wireless, a mobile or fixed device, and that's really where I think the first wave of large growth, second wave of large growth happened. And then, actually we didn't talk about this previously, but in the 2003-2004 timeframe, we did a specific chipset with a USB interface so that we could go in all printers, and opened up that market. And there were the single chips and the desire to build into phones, which is why Qualcomm bought Atheros, and that's obviously given another huge boost to Wi-Fi connectivity. Now that you have incredibly low-cost mobile Wi-Fi, it can go in anything from a thermostat to an automobile. And so there are a fair number of cars that now have Wi-Fi built in. And folks, I think they have it built in that haven't necessarily turned it on because they haven't figured out what they're going to do with it. But I would expect, like in the next year or two, you're going to hear all about Wi-Fi in automobiles. So there's just, application after application where things that make sense to get connected to the internet are going to use Wi-Fi to do that.
It's great. It reminds me back in 2001, we did at Atheros, we did a promotional video with Mercedes of future connectivity, and it actually showed, a Wi-Fi connected car back in 2001. So it's now happening.
Oh, it's definitely, my car has Wi-Fi.
Yeah.
And in the late 90s, when business users were on Wi-Fi, that would be executives or technical people with a need?
Well, so I think it's tough to know exactly, right? Companies like Microsoft would go full campus, or Cisco would go whole campus.
But it was laptops.
It was laptops. It was people had to have laptops.
So conference rooms is where it started.
That's correct.
Right?
Yeah.
And then people realized, geez, I'm moving cubicles around all the time, and why do I have somebody restring the Ethernet when I move my cubicle configuration? Let's just put access points in ceilings, and everybody can connect wirelessly everywhere.
Yeah.
And then Apple's airport obviously was named after airports, but how public shared spaces, were those important early or is that still a tiny part of the market?
That actually, so interestingly, it's finally becoming a bigger part of the market. It really was a huge push from it was part of the Centrino campaign, was hotspots back in 2003, 2004. I remember when Centrino kind of had a two-part logo that had Centrino and Wi-Fi hotspot, and arguing at the Wi-Fi Alliance meeting that was a misuse of the Wi-Fi logo because it was really a Centrino, right? There was really a Centrino promotion, but the Wi-Fi industry, the Alliance was so excited about having Wi-Fi logos everywhere, they weren't thinking about what the actual marketing message was.
And if I remember, they spent $1 billion on promoting Centrino. That number sticks in my head. So it was significant.
It was
significant budget.
Yeah, but the hope was, right, and there was a company called Wayport that got bought by AT&T. There were some other folks that were doing public access Wi-Fi. The economics just didn't quite work. And now it does, because whether it's cable companies looking to create stickiness for their home users, or cellular providers looking to have mobile offload, or there's just a variety of reasons to have public hotspots.
Right,
really
and the
make
Starbucks
economic sense.
coffee was a big deal too. They did with AT&T, if I remember.
They originally did it with AT&T.
Right, and that was another one of the big breakthroughs of making free public Wi-Fi available.
Yeah.
And hotels were huge early on.
Yeah, but the hotels started charging an arm and a leg initially for it, right? It was $20 a night, and when you're staying at a $100 a night hotel, that seemed a bit of a ripoff.
Yeah, yeah. The whole hotel. We focused at PowerCloud. We wound up doing some studies on hospitality, because what you end up with is hotels either would put in enterprise infrastructure to guarantee high performance for their users, but then have to charge customers for it, or they'd put in consumer access points and give it for free. And so you wind up with this. And by the way, it was the same opportunity that we saw in small business, where small businesses either pay for enterprise infrastructure or they go with the consumer solution. Mostly they would go with the consumer solution. And what we saw at PowerCloud was the opportunity to leverage what was pretty powerful consumer hardware, give it features and functionality from the cloud. So you have the same cost point, but now you can actually do some of the more interesting things and do it at an attractive price. So there is this fill in the middle, which I think still, there's still a gap for small business going to Wi-Fi that's rapidly getting filled with lower cost infrastructure solutions, cloud managed solutions that are built on these low cost chipsets that were originally destined for the consumer.
Right. It was interesting too, because Wi-Fi in laptops went from 0 attach rate to 99% in a very short amount of time.
Yeah.
And part of it was driven by the desire for thinner laptops, and an Ethernet physical connector forced some restrictions on the Z thickness of the laptop. And in fact, most laptops today have no wired Ethernet at all. Which is fascinating.
It is.
Yeah. Great. Well, thanks again, Jeff.
Thank you.
Thank you both.
Sure.
Really wonderful.
Yeah.